Good morning, everyone. Thank you so much for joining this session. Today we are here for our A-level mathematics seminar 2026, and we are looking at empowering the mathematics education and bridging the learning gap with ICT integration. Would like to thank the Ministry of Education and Sports and all the different organizations that are making this possible. Our session today will run up to 2 p.m. We are going to start with an opening prayer, and I'm going to invite Mpoma to lead us in a word of prayer. Mpoma School, kindly take us through the word of prayer.
Thank you. Our school bells, let's have ourselves for the prayer. For the numbers and the Holy Spirit. Our Father, who art in heaven, hallowed be thy name. Hallowed be thy name. In name. Blessed is thy name. Forgive us our trespasses, as we forgive those who trespass against us. Lead us not into temptations, but deliver us from evil. For the kingdom, the power, and the glory is now and forever. Amen. Let our loving Father, would like to thank you for the gift of this day. We would like to thank you for the gift of this new day. We'd like to thank you for the gift of life. For you to already come to our life. Father, God, loving Father, again, thank you for the gift of this seminar. Many people outside there wish to be in school, and many people outside there wish to get such opportunities, but who are Father to get this opportunity online. Father God, loving Father, as we are waiting for this seminar, may you help us understand everything that we are going to teach us. May you help our facilitators teach us so we will start family them for you. You may put into practice whatever you are going to teach us for you. Father, we pray for everyone who is planning to join the seminar. May you help them with the money so they can buy the data to join this seminar on it. We pray for our parents outside there also on it. May give them money to even before for our school fees and even next time. So maybe able to teach our final exams. In Jesus' name I pray. Amen. In the name of the Father, and of the Son, and of the Holy Spirit.
Amen. Thank you so much, Poma Girls, for the word of prayer. Would like to welcome everyone. Thank you so much for joining this session. We are going to have a few introductions, and I'm going to request the schools to have their cameras on. Have your cameras on such that we can be able to see the different schools that are joining. But I'm also going to ask the teachers to use the chat to type in the name of your school and how many students are joining from your school. So kindly have your videos on. Have your videos on. So what we are seeing on the screen, that is Impoma, that have led us in a word of prayer. Yes, you can have your videos on such that we can see which schools have joined in this session. Okay, that is very good. So dear participants, those are some of the schools that we have, and I know many others are going to be joining us in the due course. We want to welcome you. Thank you so much for joining. More other schools are going to be joining us. They are still connecting, and I request the teachers to take some photos of the students when they are seated in those main halls, and even the kind of connections that you have used. We are very happy to have each one of you, and I want to give you assurance that by the time we shall leave this session today, you would be a converted student. You'd be very, very different, and feel free to ask any concepts that you wish to know. And I want to give you assurance that we are going to give you our best, such that each one of you is in very good position to do his or her exams very well. I want to welcome the different presenters. When I look at the in the chat, I've already seen the presenters that have already joined in. You are most welcome, dear presenters, and also the schools that have joined. At this point, allow me now to welcome the Principal Education Officer from the Ministry of Education and Sports to officially open up this session. and we start. You are most welcome, Mr. Ronald.
Okay. Thank you, Mr. Kaziba. I hope you can hear me well.
Yes, we can.
Okay. Good morning, dear students. Good morning, teachers. Good morning, administrators, and every other person who is joining. I want to thank the good Lord who has brought us together once again and wish everyone a good day. Thank you to the schools who are making this possible, and we are very happy that we are joining together to learn as a team. The Ministry of Education and Sports supports this collaborative learning, and very recently, through the Uganda Secondary Education Expansion Project, we were able to place a laptop, a projector, and a screen in about 1,400 schools to support collaborative learning. But also in the last 5 years, the ministry has partnered with the UCC to equip about 200 plus schools with good internet connectivity to support ICT integration. We also know that in 2019, UNESCO resolved to promote open education resources where we all collaborate and share reading and learning materials freely. And this is what we are seeing happening in such a virtual seminar. As a department of secondary education at the ministry, we support collaborative learning in schools, and these virtual seminars are part of this arrangement. And we are so happy that Mr. Kaziba and your team, you are championing and helping us to move on in this direction. Dear students, your class is the first cohort that undertook the competence-based curriculum, and we are happy for the far you have come, and we are wishing you the very best because you are our flag bearers, and we expect a lot from you. I want to wish everyone a good day today. We will be here to support you, to listen in and enjoy your discussions. And at this point, I would like to declare this session open. Thank you.
Thank you so much, Principal Education Officer, and thank you so much for the support we are receiving from the Ministry of Education. We are now going to kick off with our discussions. I want to call on our discussant to prepare. I'm going to first have a simple brief and then we shall start. But I'll ask our first presenter, Ivy Kengoma, to prepare, and then Rena College prepare as well. You'll be the second, and then the other schools that have been able to prepare for the discussion kindly as well go on and prepare. So I'm going to share my screen now. Now, the mathematics paper, our structure or the new structure that we are following is that your math paper has two sections. We have section A and we have section B. And the time for the paper is 3 hours. So you are going to be doing these papers for 3 hours, and we have 5 items. So in paper 1, you have 5 items, and also in paper 2, you have the 5 items. However, in each of those papers, you have what we call the compulsory item. So in paper 1, there is one compulsory item, and also in paper 2, there is a compulsory item. Then in total, you are going to be doing 3 items. So in paper 1, you'll be doing a total of 3 items, and also in paper 2, you'll be doing a total of 3 items. What does it mean? It means that as a candidate, you need to plan better on how you are going to attempt the 3 items within the 3 hours. Meaning that the time you are going to be spending on each of the items is crucial such that you do not waste the time and you are able to finish within that. Now, how does paper 1 look like? Now, in paper 1, we have the 5 items. And when you look at section A is the compulsory item and it is about mainly geometry. Now, under geometry, which topics do we find under geometry? Now, in geometry is where you have what we call the coordinate geometry 1 and what we call coordinate geometry 2. That is what we have under geometry. Then we have what we call trigonometry, and then we have what we call vectors. Now, that is what you are going to be finding in that area. Now, when we talk about coordinate geometry 1, what do you find under coordinate geometry? Coordinate geometry 1. Now, under coordinate geometry 1, that is where you went on and looked at things such as you looked at Cartesian coordinates, you looked at things like midpoints. That's where you went on and looked at things like gradient, midpoints, now perpendicular distances. Now that is what we call coordinate geometry 1. Those are the things you looked at. Then when you went to trigonometry, that's where you looked at things like R formula, the T formula, solving angles, trigonometric equations. That was trigonometry. Then you had vectors. The vectors, you went on and looked at distances. You went on and looked at the vector equation of a line. You looked at collinearity and the rest of that. Now that's what you are going to find under vectors. Then when it comes to coordinate geometry 2, that's where you find mainly the locus things. That's where you are going, that's where you have found things like circles. Now that area is what we call coordinate geometry 2. Now, as you are preparing, it means that now you need to prepare very well for this section. When they are setting an item can be either just coordinate geometry 1 or 2. It can be trigonometry alone, or it can be vectors. But also a setter can go on and mix coordinate geometry 1 and trigonometry, or mixes trigonometry and vectors. So meaning that you need to be well conversant with that section. Then we have section B. Now section B, there are 4 items. And out of the 4 items, you are going to be choosing 2, whereby you choose one from here and then you make one choice from here. Now, under algebra, this is where you looked at numerical concept things. This is where you looked at polynomials. That's where you looked at things like indices. That's where you looked at things like surds. That is numerical concepts. Then you looked at equations and inequalities. Then you looked at permutations and combinations, series, and then complex numbers. Now here you are going to be finding 2 items in this section of algebra, and then you go on and you make one choice. But when they are setting an item can mix 2 or 3 of them, or even can mix all of them. Meaning that now the 2 items that are coming from here, you need to prepare them. That the item is not that is going to come from only numerical concepts, but a setter can mix numerical concepts and equations. A setter can mix equations and permutations, or it can mix series and complex. Then the second part is what contains the calculus. Now calculus, you looked at partial fractions in senior 5, you looked at differential equation 1 and 2, differential equation senior 5, differential equation senior 6, term 1. Then you looked at integration 1 and 2 differential equations. Now that is calculus. Now under here, you need to be very, very, very key. This is where you find the differential equations. This is where you're going to find things of areas. This is where you're going to find integration and differentiation. So a number can come whereby they have given you a number and the number has partial fractions, has integration combined. But also a number can come where it has differential equations, it has partial fractions. Now that is how paper 1 is going to be looking like. Now we have the paper 2. Now still paper 2 has these 2 sections, has section A and has section A, which is mainly about numerical analysis. So under there, you're going to find things of approximation approaches. That's where you're going to find trapezium rules. That's where you're going to find iterative methods, the Newton-Raphson methods. That's where you're going to find the flow charts. And now this is the compulsory part, and this is the compulsory section. Then under section B, you are going to find things of data analysis and probability, and then the dynamics. So here you choose one item, also here you make one choice, and also here you choose one. And then in total, you are going to be able to do the 3 items. Now, when it comes to descriptive statistics, this is where you're going to find your things of mean, mode, median, standard deviation, variance, quartiles. That is under descriptive statistics. Then you're going to find correlation and scatter diagrams. This is where you're going to find probability theory and then random variables. So that is under data analysis and probability. Then we have this second section of dynamics, or what you call the mechanics part of it. Now under mechanics, this is where you're going to find the resultant, friction, connected particles, resultant. Now what does it mean? It means that mechanics, there is an item. It is not like a compulsory thing that you must be able to do at least an item from mechanics. So I want to call on you that do not do anything like specialization, that I'm going to specialize here. No. When it comes now to reading, to practicing, you are going to be doing everything such that now you are well conversant with every section. So that is the structure of the papers that we are going to be doing. So allow me now to stop sharing, and then I'll share with you now the seminar items that we are going to be discussing. I'm taking an assumption that you have been able to receive the seminar items, and when you look at the seminar items, those items were organized in the different sections. So it was organized in geometry. Then from geometry, we went on and took you through algebra. And now in algebra, that's where you do one item, but you make a choice. Then we went on and looked at calculus, and then we went on to paper 2, and then we went on and finished up to paper 2. Now these are the items we are going to be discussing in our session. Now in case you have not yet received them, we are going to be sharing them with you in the chat such that you can be in position to access them, such that you can be able to follow up the session. At this point, now allow me to invite our first presenter, Kengoma Ivy, to take us through her presentation. Ivy, you are most welcome.
Thank you so much, Shakaziba. Good morning, teachers, administrators, and fellow students. My name is Kengoma Ivy, and I'm a student at Taiba International School in Senior 6. So today I've prepared, and I'll be taking you through item 2 of the questions teachers just shared under the first construct of paper 1, which is geometry. Before I begin presenting, I would like to ask that the schools allow me to present, then the questions will come after I've presented. So allow me to share my screen. If you can see my screen, please raise your thumb or react so that I ensure everyone is on board. Or you can type in the chat. Can people see my screen? Okay, so I'm going to assume that everyone can see my screen, and I'm just going to continue with the presentation. Okay. So item 2 reads, a renewable energy company is testing an automated solar tracking system before installing it at a commercial solar farm. The horizontal displacement D in centimeters of the tracking arm from its reference position is modeled by D is equal to 12 cos theta plus 16 sin theta, where theta is the angle through which the tracking arm rotates during one operating cycle. The manufacturer recommends that the tracking arm should maintain a horizontal displacement of at least 15 centimeters for efficient collection of solar energy. The findings of the investigation will be used to determine whether the proposed tracking system should be installed at the solar farm. Tasks: A. Determine the operating positions of the tracking arm during one operating cycle, and then B. Using your findings, recommend whether the proposed solar tracking system should be installed at the commercial solar farm. So after reading a scenario, as a learner of the new curriculum, the first thing that you have to do is to begin unpacking and start thinking of what the scenario requires of you. We have just been told that under geometry, we have three topics, which are trigonometry, vectors, and coordinate geometry 1 and 2. So when we read through this question, the first thing that we can spot is that there's trigonometry in this item. Why? We see cos and sine theta. So when we look through for other topics, we don't see the vectors and we don't see the coordinate geometry. So after identifying that the topic required for this to answer this item is trigonometry, you now have to start thinking about what concept are they looking for under trigonometry. So when I look at the expression, rather the expression they have given us here of D is equal to 12 cos theta plus 16 sin theta, it has to, like, a learner has to now start thinking of R formula. Why R formula? When let me just annotate so that I highlight. Okay. When someone sees an equation like this, the first thing they have to look out for is the degree of the cos theta and the sin theta. Once a learner notices that the degree of cos theta is to 1 and the degree of sin theta is to 1, and they have been asked to find the values of theta, a learner has to now apply the R formula. When we read task A, it tells us determine the operating positions of the tracking arm during one cycle. And they tell us in the scenario that theta is the angle through which the tracking arm rotates during one cycle. So basically, we are finding theta. Okay. Continue. So I had a brief, let me just remove this, sorry. Okay, so I had made a brief summary of what the R formula is all about. So we have been given this expression, and we have to now express it in form of the R formula, and I've explained why the R formula is needed in this scenario, because we have sine and cos to the degree 1, and there's usually either addition or subtraction that's here. So either see an addition sign or a subtraction sign in this scenario. I've also put the uses of the R formula. For those who might ask, why do we need the R formula? The first reason is to combine the sine and cos terms into a single trigonometric function, to simplify trigonometric expressions, to solve trigonometric expressions, and to find the maximum or minimum values of expressions. So take note of this. We say that when we are expressing the R formula, we are going to say R cos theta minus beta. This is relation to this. So when we have A cos theta plus B sine alpha, we have to recall the compound angles. Let me just go to that slide. So here we have the compound angles. So when we are given sine A plus B, the first thing that we have to do is to expand. And you can see we have expanded to get sine A cos B plus cos A sine B. Then for sine, we notice that when there is a plus here, there's also a plus here. When there is a minus here, there is also a minus here. However, for cos, we notice that when it's cos A plus B, then we have when there is a plus, when we are adding the cos A plus the cos B, we notice that here it becomes a minus. And when it's a minus, here it becomes a plus. So that's one key thing. But in our formula, we are not going to use A and B, but rather we'll be using theta and alpha. Okay, let me just erase. I hope we are all at par until that point. You could put a thumbs up in the chat. Okay, back to this. So here they have told us that to get our R, we get the square root of A plus B, A squared plus B squared, and to get the tan alpha, we get tan alpha by saying B over tan alpha is equal to B over A. But someone may ask how tan comes in. How tan comes in this scenario. So when we look here, we see that we have r sine theta divided by r cos theta. So when we eliminate the r's, we remain with When we eliminate the r's, remain with tan theta. But remember, we said r sine alpha is equal to b, and r cos alpha rather is equal to a. So therefore, our tan alpha is equal to a over b over a. So after that brief introduction, I'm going to get into the solution for item 2. So the first thing I did was to express d in the form of cos theta minus alpha. The reason I said cos theta minus alpha was because the expression given to me was 12 cos theta plus sine alpha. So I had to remember my compound angle, which what begins with cos and ends with sine. So remember that when we look at our r cos theta minus alpha, we have cos beginning and then we have sine here. Yes. So since it's a positive, it's a negative here. And I think we already took you through why that is the way it is. Okay. So after expanding, let me just erase this. After expanding this, we compare the coefficients. So now we have 12 cos theta plus 16 sine theta, and we are comparing it with r cos theta cos alpha plus r sine theta sine alpha. So when we compare this, we see that the coefficients of r cos theta is 12, the coefficient of r cos theta is 12, and the coefficient of r sine alpha is 16. So after finding that, the first thing that we are going to do is to find what r is. So we already said that r is the square root of a squared plus b squared, and in this case, we can take the 12 to be our a, we can take the 16 to be our b, and therefore we got our r as 20 centimeters. We're using centimeters because in the scenario, we're already given units of centimeters. Okay, good. So now, we are going to find the value of alpha. So we are going to say tan inverse A over B decided to first reduce it to become 4 out of 3. I divided through by 4. So it becomes tan inverse of 4 over 3, which will give me the angle 53.13 degrees. A learner can choose to use between 2 decimal places to 4 decimal places, but preferably 4 decimal places if they are still using the angle. So therefore, the R formula already said here that it's going to be written in the form of R, which we got as 20 cos theta minus alpha. And we got our alpha as 53.13. Therefore, we come here and conclude that the horizontal displacement D is equal to 20 cos alpha minus 53.13, which was, 20 cos theta minus 53.13, which was our alpha. So when we continue reading the question, let's go back to the question. They tell us that where theta is the angle through which the tracking system rotates during one cycle, okay? A manufacturer recommends that the tracking arm should maintain a horizontal displacement of at least 15 centimeters for efficient collection of solar energy. So that means our horizontal displacement should be greater than or equal to, because of this word at least, which let me just highlight it. Okay. So this at least is telling us that D should be greater than or equal to 15 centimeters for efficient collection of solar energy. So now, let me just go back to that slide. Okay, so now we have to solve for when D is 15, when D is 15 centimeters, are we able to get that efficient production of solar energy? So we first equate that D to we have to say 20 cos open brackets theta minus 53.13 degrees, which is our alpha, is greater than or equal to 15 centimeters. So the first thing we did was we divided by 20 on both sides of the inequality sign, so that we were able to get cos theta minus 53.13 is greater than or equal to 0.75. But if we continue with this theta minus 53.13, it may become a bit hectic or confusing for us. So I decided to make theta minus 53.13 phi, so that we can continue with cos phi is greater than or equal to 0.75. So after getting the value of phi as 41.41 degrees, remember we said that phi is theta minus 53.13. So since I remember that cos is positive, because remember we had a positive 0.75. So when we draw the quadrant, we have our 41.41 here. So when we the first quadrant, cos is positive, so we remain with 41.41 degrees. But now when we come to the fourth quadrant, we find that this is going to be negative. Sorry. This is going to be negative because we are coming in the clockwise direction. And we say that when we are reading an angle from the clockwise direction, the angle becomes negative. So therefore, I've been able to get the range of my phi. Remember, we are finding the range of the tracking arm, its revolution. So I came here and noted that one revolution or cycle is between 0 degrees to 360 degrees. So now I have to go and substitute back for theta. So I came here and I put that negative 41.41 degrees is less than or equal to phi less than or equal to 41.41 degrees. And then I substituted for my phi, which was theta minus 53.13 degrees. So to get theta alone, to get the range for theta, I had to add 51.13 on all the three terms of the equation we have here to get our range for theta as 11.72 degrees and 94.54 degrees. So after that, we conclude and say, therefore, the operating positions, just a minute. Okay. Therefore, the operating positions of the tracking arm during one operating cycle, which said the cycle is from 0 degrees to 360 degrees, are 11.72 degrees and 94.54 degrees. So we need to keep in mind that when we are concluding, we can conclude to 2 dps or 4 dps. That's the range. Yes, and always make sure to have a conclusion because it's key in the new curriculum. Okay, so now we have not finished the item. It still has a part B. We have solved part A. I'm just going to go back to the scenario and see what it says. So we have determined the operating positions of the tracking arm during one operating cycle. So part B is now telling us, use your findings and recommend whether the proposed solar tracking system should be installed at the commercial solar farm. Okay. So the first thing that we have to find out is the range of cos theta. So we have to find the maximum displacement of D. And we already said that our D is equal to 20. Let me just go back. We already said our D is equal to 12 cos theta plus 16 sin theta, right? So we have to now find the maximum and minimum values. Why are we finding the maximum and minimum values? Because they say that for the efficient collection of solar energy, we need to have at least 15 centimeters of the horizontal displacement should be at least 15 centimeters. So we need to see what's the maximum displacement of the solar tracking system. So we find the maximum value. But someone can ask, what's the range for cos theta? So cos theta, if you look at the cos graph that I put here, we have the maximum being +1 and the minimum being, let me just annotate, we have the maximum being +1 and the minimum being -1. So you should always remember that cos theta has a range of -1 and +1. Okay. So when we are finding the maximum displacement, we are going to say 20. We're going to say 20 times 1. Someone may be asking why we are only multiplying 20 times 1. When we go back to the R formula, when we go back to the R formula, and you have been asked to find the maximum and minimum values, or the maximum and minimum displacement in this case, to get the maximum displacement, we are going to get this times our maximum value of cos theta, which is going to be 1. So it's going to be 20 times 1, 20 times 1, which is going to give us 20. And when we are finding the minimum value for cos theta, we are going to get this 20 times -1, 20 times -1, which is going to give us -20 centimeters. However, a learner would have already noticed that we don't need the minimum value because we are looking at the values that are at least 15 centimeters. So greater than 15 centimeters. So Alana will just be looking for the maximum value. And then when you want to find the angle at which the angle of the tracking system when it's at 20 centimeters, we are going to say cos theta minus 53.13 is equal to a maximum value, which is positive 1. Then the angle at which it's minimum, that is the angle at which it's at negative 20 centimeters, we are going to say cos theta minus 53.13 degrees is equal to negative 1. Okay, let me go back to that slide. Okay, so we have found that its maximum displacement is 21 centimeters, and now we have to find the angle at which it occurs. So we are going to say that cos theta minus 51.13 is equal to 1. Why 1? Cos theta has a maximum value of 1. If you press into your calc, to get any angle of cos theta, the highest angle, sorry, okay, cos inverse 1. Okay, so we're going to continue. When you say cos theta minus 53.13 degrees, and say it's equal to 1, so we are going to bring cos on this other side. We get cos inverse of 1, and cos inverse of 1, we are going to get, if you type into your calculator, cos inverse of 1 is equal to 0. So when we add 53.13 plus 0, because we're being 53.13 to this other side, to make theta the subject, we're able to get the angle at which the maximum display, the angle at which it's 20 centimeters. So when it's 20 centimeters, the angle of the solar tracking system is 53.13. Then after that, you're going to conclude and say, therefore, therefore, the proposed solar tracking system should be installed at the commercial solar farm because the maximum horizontal displacement of 20 centimeters is greater than the required 15 centimeters for efficient collection of solar energy, meaning that since the maximum displacement is greater than the required 15 centimeters, there's going to be efficient collection of the solar energy. And after I finish concluding, yes, you are done. So you can come back and check if there's anything you have missed in the scenario. And I think that's it. I think those who have questions can raise their hands. Yes, thank you for listening.
Thank you so much, Ivy, for that wonderful presentation. In case you have any questions, kindly ask. You can use the chat, you can raise up your hand and then pose the question. Okay. Yes, Atwine. Oh. Atwine, ask. Okay. Hamza, you can ask.
Yes. My question is, for that question we have used RR formula, right? Now, what about me if I'm to use T formula? Can we, all of us, get maybe the same marks or scores?
Okay, good morning, Hansa. So I began by saying that the reason why a candidate or a learner would use R formula, or why it's the best for this, if not the only method for this question, is because you have to first look at the equation they've given you. Here they have told us that D is equal to 12 cos theta plus 16 sin theta. When we look at this, we have been asked to find the angles theta. So when you have been given an equation in this form, and you have been asked to solve for the angles of theta, the best method would be the R formula. So I don't think T formula can apply here. I don't know if Mr. Kaziba has anything else to add.
Thank you so much, Ivy. To add on what she has said is that you need to look at, for this particular item, you were required to find the maximum, and then there was a concept of maximum, meaning that if you are to use your T formula, you can only be getting part A, you can get the operating positions. But when it comes now to part B, you'll be off because T formula, you will not be able to get the maximum for the what? For the displacement that they want. But I'm going to talk about it after her presentation. There is a concepts. There are some concepts that I'll be bringing on board. Daban. Okay. I think I've Atwine.
Yes, good morning, sir. Thank you. There is a step where I saw her where there was an inequality sign and she divided both sides by 20. I was inquiring and asking whether when we divide, the inequality sign changes. Thank you.
Okay, thank you so much for that question. When it comes to dividing with the inequality sign, the sign will only change
Okay,
if we
this is
divide
Davani
by a
girls.
negative value.
Okay,
Uh, Dabani, could I first finish responding? Okay, so the sign of the
this is Davani
inequality
girls.
only
My question
changes
is
when we divide through by a negative number. Let's say if I divided by negative 20, then the sign would change. But since I divided through by positive 20, the sign is not affected. Let me just go to that slide for clarity. So you can see I divided by positive 20. So the sign stays the same. I don't know if I've been able to answer your question.
Firstly, I think there is a problem. They are not hearing you.
Okay, thank you, Ivy. Daban girls, you may ask.
Okay, you try to talk. Talk.
okay. For Davani's case, my question is, I didn't. Okay, I beg your pardon on that explanation of why you choose the area which was equals to 20 centimeters to use it for maximum when you're getting the maximum displacement. I didn't get your explanation very well, so I beg your pardon.
Okay, thank you so much. So the reason why we equated the R to the maximum value, 1, is because when we are finding the maximum displacement, there are two things that come with it. You find the maximum displacement and you can also find the angle at which that maximum displacement occurs. So in this case, what we are looking for was the maximum displacement. So when we are finding the maximum displacement, or rather the maximum value, we are going to multiply the R, which we got as 20 centimeters, by 1, because 1 is the maximum value. Then when we are finding the angle at which the maximum displacement, or in like another case, the maximum value occurs, we get this cos theta minus 53.13, and we equate it to the maximum value, which is 1, so that we're able to get the angle at which the maximum value occurs. I don't know if it has been able to make sense now. Oh,
Okay,
you
thank you
understand?
so much.
You're
I've
welcome.
understood. Then the other part of where I took a range of negative 41.41 and the positive side, I didn't understand why you choose that range, that
Okay,
very
the
part.
reason why I took the range, if I'm to go back here, we had this, we had cos inverse, a minute, okay, cos inverse of 0.75, and we got the answer as 41.41. But remember our range, because they told us that one cycle or revolution has a range of 0 to 360. So I had to use the quadrants, or okay, where we have okay, I put the quadrant so that I could find the angles in that range. But remember, this phi is, go back. This phi is theta minus 53.13. So I was just using this range so that I'm able to find this range here, the 11.72 degrees and 94.54 degrees. So that you can see this falls under my range of 0 to 360. So it was just something to help me come up with this range. I don't know if I've made sense there.
Okay, thank you so much.
Okay. Uh,
I think we are going to have one more question from Kalawa or from Tekino.
Yes, good morning, everyone. I'm Kara Provis from Notre Dame High School, Masaka, and I would like to ask the question, what if the original equation has a constant whereby this time around it is d equal to the other equations? Then when we are given like 20 is equal to the other equation, how do we do it? And another question is, what if I follow the equations that you gave that r is equal to the square roots of the other coefficients? Does it work or till earns me a negative in the max I score?
I
Thank you.
didn't quite get your second question. I don't know if you could, like, I don't know, package the question differently, because for the second part, I understood. I think you're talking about this R, which is here. I think this can best explain it, how we get the value of R. We just
Yeah.
get the square root of A squared plus B squared, and in this case, our A squared, let me just go there. Person who is writing on the screen, if you could stop, it would be amazing. Our A squared is basically the coefficients, okay, of R cos alpha and R sin alpha are what we are squaring to get the R. I don't know
Okay.
if I'm making sense.
Yes, it makes sense. But I was asking another question
Yes, please.
that this time around we're having d equals 12 cos theta plus 16 sin theta. What if we are
Yes.
given like 12 is equal to 12 cos theta plus the 16 sin theta?
Let me just write down what you're saying. You're saying 12
Yes, let's say 12 is equal to the other equation,
is equal to
to 12
this
cos
equation.
theta. Yes.
Uh, yes, we can still use the R formula, because
Yeah.
if we have something like this, so forgive the handwriting. Uh, sorry. Let me just. If you have something like this, I feel like the R formula can still be applied, but maybe just even you can come in and explain more.
Okay, thank you.
Okay, like you have said, Ivy, still we can apply the R formula, but I think you can first make your conclusion, Ivy, then I can summarize at once.
Um, okay, my concluding remarks are, uh, when you're answering the R formula, you have to know two main things. One, you have to know the compound angles. What are the compound angles? They are these ones here. The sine A plus B, sine A minus B, cos A plus B, cos A minus B. And I know as learners, we tend to rely on the logbooks, but if you could sit down and understand them, the better for you. And then the second thing that I would have to say is that for maximum and minimum values, which is usually a question that they like bringing with R formula, usually part B, like we have seen, you have to know the ranges of cos theta, sin theta. Yes, and also I don't know if tan has a range, but let me focus on those two, sine theta and cos theta. You have to know that the maximum value will always be 1 and the minimum value will always be -1. I've tried to draw the graphs here so that you can see when you look at the maximum here, it's at +1. Then you look at the minimum, it's at -1. So you have to know that range. And then the last thing I have to say is that for every part, conclude. You can see how I had a response and conclusion. And this new curriculum, you have to make sure that you respond to the task given. You can see I've responded to the task given so that you are able to get the full marks. Thank you so much for listening to me, and I hope that I have been able to understand. Allow me to stop sharing my screen.
Yes, thank you so much, Ivy, for the wonderful presentation. Allow me to start from where she has stopped. Now, dear students, the number we have been dealing with is trigonometry, and I want to emphasize two things. For this particular item that she has been able to do for us, you could applying whenever you find an equation, whenever you find an expression, there are two things I want you to bring to your attention. That whenever you find that I have a cos of theta plus or minus b as sine of theta. Now, any equation in this kind of form, whether you have 2 cos of theta, maybe plus 3 sine of theta, maybe you have 3, maybe sine of theta, minus maybe 5 cos of theta. Any trigonometric equation you have in this form can be solved by using two approaches. It can be solved using the T formula, or it can be solved using the R formula. But the choice of which approach to use must depend on the scenario you have at hand. Now, if you read through your scenario and somewhere you need to apply things of maximum or minimum, then that means that that is a clear indicator that now you are going to use, you are going to go on and use the concept of our formula. The moment you read through and then you see that at one point I have to use maximum or minimum, then you run very fast and know that for that case I'm going to use what? To use our formula. Then number 2, I want also you please to take note that when you are solving such, the approach or the method or the choice to use is very important. Sometimes they may give you a good hint. They may tell you that the manufacturing company wanted to express it as a single trigonometric function. Now, if they have given you a hint of such a nature, then that is automatically that you must use what? Ara formula. So now you need to know which approach to use depending. Now, I want to bring now to your attention that whenever you meet a scenario, when you are approaching a scenario, I want these 4 things to always come into your head. Number 1 is what we call concept identification. Whenever you get a scenario, I want you to always first identify what is the concept in the scenario. The concept is the mathematics hidden in the scenario. That if they have not told you the topic, what is that mathematics hidden within the scenario? Can you be able to identify the variables? Can you be able to extract the constraints? Can you be able to recognize the appropriate representations? That's what we call the concept. Now, whenever you read through the scenario, identify what is the concept in this particular scenario. The concept tells you what mathematical idea is being involved in this particular scenario. Number 2, the method selection and application. You need to know which method am I going to use? Which method am I going to use to manipulate this concept that I have obtained? So, which procedures am I going to be mathematically varied? Which formulae am I going to use? Which transformations am I going to use? Which diagrams, which domains, which assumptions, which numerical methods are appropriate for this particular scenario? That's what we call the method selection and application. Now, for that particular item we have been dealing with, any learner who uses the T formula, you have not selected the right what? The right method. Much as the T formula can work, but is the method the right one? Much as it can drive you to the mathematics, but your selection for the method is not the best. Then from there, you go to what we call the accurate output. Like during the discussion, Ivy has kept on emphasizing about the angles. When you are getting to get the accurate output, it means that you must avoid what you call premature approximation. When you are writing your angles and you are still using those values, please continue writing to very many decimal places. Don't write to 0 decimal place unless the question has stated so. So continue using 2, 3, 4 decimal places such that your value you are going to get at the end is accurate. Then the last one is what you call interpretation and decision, what she has been calling conclusion. Now, whenever you are concluding, whenever you are making your conclusion, go back to the original scenario. Compare your output with the stated criterion and or threshold within the scenario. And then you justify your judgment and then answer the actual task. For whatever item you are going to do, we no longer want to just have the mathematics of you calculating that theta is 53.13. But can you make sense from this particular output you have obtained that yes, this is an accurate output? But have you gone on to make that conclusion that now on this particular item, this is the interpretation and this is the decision? So whenever, dear students, you receive a scenario, whenever you receive this item and the tasks, first identify what concept is within the scenario, which method is the best to use. I know you know very many methods, but always there is the best choice for the method. And always I want you that after reading the task, let me say you have read part A, first read also part B, because sometimes you'll find that part A and part B are correlating. There is some knowledge from part A that you are going to need on part B. Now, these are the 4 major things that you need when you are approaching any scenario. Take an example. I'm going to use the UNEB sample. When you receive such a scenario, I want you always to first identify what. Now, I want to tell you that for any scenario you are going to have, you are going to be receiving what I am calling a clue about a scenario. A clue tells you what mathematics is hiding inside. Then after getting the clue, I want you always to identify what is the concept, what mathematical idea is involved. Then from there, have the methods and the method that you are going to use, and then go on and get your output, interpret and make a decision. So when you read through here, you will notice that in this scenario, I want you always to first identify the mathematics, identify the clue that they have given you, which tells you the kind of mathematics hidden in this kind of what? In this kind of scenario. Now, if it is for this particular scenario, I'm going to go as a student, I'll keep on highlighting the different clues that they have given you. So those different things you keep highlighting that there is mathematics. As long as even you say dig it, that there is mathematics here, that there is mathematics minimum, this is mathematics, there is a big clue here, an approximate method. Now when they talk about approximate method, then you need to know which methods are those. So you keep on highlighting those different clues at exactly 5-meter interval. Now, those are what we call the mathematical clues. So for whatever scenario you have, there are clues that are going to drive you onto the concept. And then from the concept, you are going to be able to identify which method you are going to use to attempt that scenario. Now, if it is for this one, I want to give you an example that if it is for that scenario, the first thing, the evidence from the scenario, what is it that shows you the mathematics that from that scenario there is something measured, the measurements at exactly 5-meter interval. Now you need to know that 5-meter interval is talking about what we call equal intervals. And they told using an approximate method. Now the crew in the scenario is looking at area. And then you know that now for if it is such, which concept am I going to identify? That the concept I'm going to identify is going to be approximate integration. And now which method am I going to use? That I'll use the trapezium rule. That if it is exact method, then you need to know that there I need to evaluate the integral from 0 and maybe to 20. That if it is this, now those are the different concepts I want you, that whenever you read the scenario, identify those concepts, identify. Now for this particular one that IV has been doing for us, you note that she was able to identify that this is the mathematics. She went on and identified that during one operating cycle. Now, this is the mathematics. We shall not tell you that your angle should be between theta and 300 what? 60. Now, this is the direct one. But now you need to know that in one cycle, how many degrees do we have? How many revolutions do we have within one cycle? Look at the mathematics, at least 15 centimeter. Now you need to know from your O level, when you are looking at inequalities, when you are looking at equations and inequalities, what did at least say that is a mathematical symbol for greater than or equal to? Now, those are the different hints, those are the different clues that you have to look out for in the scenario. And whenever you are looking out for the scenario, dear students, never leave a scenario without solving the problem that is embedded within that particular scenario. Now, those are the 3 things that you need to identify. So if I'm to break this scenario, I'm going to first have evidence from the scenario. That evidence from the scenario, they gave us the equation. They gave us this equation. Sometimes it can be an expression. Sometimes they can be words within the what? Within the scenario. Those are the ones you look out for. So then, what is the clue? Now, the clue you need to remember from your harmonic expressions when you are looking at trigonometry. Then after that, you identify which concept am I going to use when I'm dealing with such an item. So those are the few things that you need to look out, and then you know which approach you are going to use. Then I want you that whenever you are approaching these scenarios, have subtitles. What are you using? If the method is clear, I identify that now here using the ARA formula. Show us which kind of concept have you been able to identify that I'm going to use the ARA formula. Indicate it there. That is the subtitle. So you are identifying the concept from the scenario that you are going to be applying. And then after you go on and have your output, then have your conclusion. So that is what you can do when you meet these scenarios. So I'm going to first end here and then I stop sharing my screen as we get the second presentations. So I will be making comments depending on what you have. So the next course, they are going to be able to identify for us the concept within the scenario, what gives us the clue from the scenario, and which approach or method we can use to come up with the appropriate answer. Now, any step you take, I want to let you know that we are not going to we don't mark the error formula, but we look at the right substitution in the right formula with the accurate output. Those are the things that we always look out for. Allow me now to invite Rena College to take us through the second number. The same girls, kindly go on and prepare. Now, I understand that the room is full. The room is full. Other schools are not able to join. So in case you join using 2 gadgets, I will kindly ask you to log off one such that we can have space for some schools. But also we are going to start live streaming on YouTube such that those schools can get us from there. Okay, thank you. Can we have Rena College now?
Oh, okay. Good morning, everyone. My name is Katongole Griffin, a student at Rena College Senior 6 offering math. And we are going to go through question number 9, which is all about calculus. The question says, is everyone getting me?
Yes, we are getting you. I'm going to request that you put your screen in full view. That one?
Is it that one?
Yes. Yeah, no, the first, no, go back. Go back. That one.
This one?
Yeah, yes, place it.
All right. So I'm going to take you through the question. It says,
Get it back. Get it back. Your screen has gone off.
Master. This clear and same there. Sing your answer. Is it seen now? Yes?
Not yet. Not yet.
Yes.
You start sharing. You are not sharing the screen.
Is it now seen?
Yes, it is now there. Just put it in full screen and then you start.
Yeah.
Oh, no, I think there is a problem because it has gone off now. So we shall.
About there?
No, you are not sharing the screen. But just ignore full screen and then you share the way you were sharing.
That one. Okay, is it seen now?
Yes, we can go on.
Okay, let's go with that. So I'm going to take you through the question. It says, researchers in microbiology laboratory are conducting experiments on bacterial growth under controlled conditions. Sarah is investigating the growth of a bacterial culture that initially contains 100 bacteria. Laboratory observations indicate that the rate of increase of the bacterial population is proportional to the number of bacteria present. During one experiment, the proportionality constant was found to be 5 per hour. The laboratory safety guidelines require that the culture be transferred to a secure containment chamber before the population reaches 10,000 bacteria. Then, David is preparing nutrient solution for bacterial cultures using cylindrical container with a fixed surface area. He intends to determine the dimensions of the container that will hold the greatest volume of nutrient solution. Grace is calibrating a spherical culture flask. The intended radius is 10 centimeters, but the manufactured flask has radius of 9.8 centimeters. According to the laboratory quality standards, the percentage error in the volume should not exceed 8%. Then the task was part A, determine whether Sarah's bacterial culture should be transferred before the next scheduled inspection after 1 hour. And part B, determine the dimensions of the cylindrical container that will hold the greatest volume of nutrient solution. And then C, establish whether Grace's sulfurical flask satisfies the laboratory quality standards. So when we read the scenario clearly, we see that there are 3 concepts in it, where the first one is talking about Sarah, then the next one is about David, and the third one is about Grace. So to start with the first part of Sarah, they told us that Sarah is investigating the growth of the bacteria. That initially contains 100 bacteria. And we had to start and let there. So when we go through this, we find that they told us that the laboratory observations indicate that the rate of increase of the bacteria population is proportional to the number of bacteria present. So when they talk about rate, then we start thinking of differentiation and maybe differential equations. So here I had to start and let the number n be the current bacterial population. And from the information I got in this scenario, they are telling me that the rate of increase of the bacterial population is proportional to the number of bacteria present. And therefore, we had to relate the rate of increase of the bacterial population and the number of bacteria by using this expression. I say that the n dt is proportional to n. The n dt meaning that this is the rate of change, the rate of increase of the bacterial population. So by removing the proportionality sign, we put the equal sign and introduce the constant of proportionality k. And through the scenario, we find out that the proportionality constant was found to be 5%, 5 per hour, sorry. So we introduce the n dt is equal to kn, where k was 5. So we continued and substituted for k, and we got the expression the n dt is equal to 5n. And this now brought in the concept of solving differential equations by separating variables. And our first, as we go through, this last part says that the laboratory safety guidelines require that the culture be transferred to secure a containment chamber before the population reaches 10,000 bacteria. And the question was, determine whether Sarah's bacterial culture should be transferred before the next scheduled inspection after 1 hour. So that means we have to get the expression relating the number of bacteria at the current time and the time taken. And this could only occur by getting the expression relating the number and the time. So we use knowledge from differential equations, that is solving them by separating variables, and we had to change, we divided both sides by n, and then we brought the other dt on the other side. So we got an expression as the n over n is equal to 5 dt. So we had to integrate so that we get the expression relating the number of bacteria currently and the time. So you get this after integrating here, you have to be with some knowledge of integration. Since we have here, we are integrating with respect to n, So 1 over n becomes natural log of n, and then 5 with respect to t becomes 5t plus the constant of integration c. So when we continue, we have a constant, but initially they told us that the growth of the bacterial culture, the bacterial culture initially had 100 bacteria. So that means initially means that when time t was equal to 0, n, which was the number of bacteria current, was 100. So knowing this, we can go ahead and substitute in the equation and get the value of the constant c. So this is what we're doing. We substituted n and the t. So it was natural log of 100 is equal to 5 times 0, giving us c, and we got c as the natural log of 100. And knowing c, we substitute back into the expression, which was getting the number of bacteria present and the time. So we got natural log of n is equal to 5t plus natural log of 100. So after getting the expression, we have to ask ourselves now, what would be the number of bacteria in the next 1 hour, after 1 hour? So knowing the time t is equal to 1 hour, we have to get the number of bacteria by using our expression we have gotten to get to know the population at time. So by substitution, that t was 1, so the equation becomes natural log of n is equal to 5 times 1 plus natural log of 100. And by knowledge of from natural solving logarithmic equations, we know very well that natural log of n is the same as log to base e. So here we applied the law of anti-logarithm, and we got n as equal to the exponential 5 plus natural log of 100. So by solving this using calculators, we're able to find the number of bacteria n to be 14,841.3159. But since we don't have bacteria which are halves, we had to truncate the figure and take the population as 14,841 bacteria. So they told us that, so we got to know that after 1 hour, the bacteria present was 14,841. And the laboratory safety guidelines required the culture to be transferred to a secure containment chamber before the population reaches 10,000. So we find out that the population had already exceeded what? 10,000 by after 1 hour. So we concluded and said therefore, Sarah's bacterial culture should be transferred before the next scheduled inspection after 1 hour because it will have exceeded 10,000. And that was what we had for part A. So is there any questions so far? So if no question,
We can
let me
first take
welcome.
on Psalm 2.
All right.
Amulia Secondary ask.
Good morning. May you please display for us the equation? We are not seeing the equation, and even the words are too small for us to view. So we are not understanding.
Okay. So
Okay, presenter, we can kindly first continue and finish, then we shall respond. But increase on your slides such that people can view very well.
All right. So let me, for the next part, B, let me welcome my fellow to take us through that part, which was requiring us to
I would like to thank my fellow Atongwe Griffin for discussing for us part 8. My name is Rangaze from Rena College, Maige Senior 6. Good morning to you all. I'm here to present to you part B of the question. And this for David, yeah? And it goes. Let me first read through the scenario. David is preparing nutrient solutions for bacterial cultures using a cylindrical container with a fixed surface area. He intends to determine the dimensions of the container that will hold the greatest volume of the nutrients. I think this is the part which I'm working on. And the question goes B. Determine the dimensions of the cylinder, of the cylindrical container that will hold the greatest volume of nutrient solutions. As Master said, that we first identify, like if you face like a scenario, first identify the topic, then you internalize it. That means that you should dive deep into the scenario in order to understand it better. Let me first go back to the scenario and point out some main concepts in it. Here it goes. Using a cylindrical container with a fixed surface area. If you have like a pen there and you have the equation, you can underline a fixed surface area. And then another thing goes. He intends to determine the dimensions of the container that will hold the greatest volume of the nutrient solution. And to me, if I hear like the greatest volume of the nutrient solution, I just come to know that is what? That's differentiation. Is it differentiation? And the greatest volume, that means that they are meaning the maximum. And then a fixed area. That's our area we are going to take it to be what? To be then we start. Here, I first let, because they never gave us any symbol of area. We first we define the main concepts. Let the area of the surface, let A the area be the surface area of the cylinder R of the cylinder. R be the radius, and H be the height of the cylinder. And from there, we know very well that the cylinder has two circles, is made up of two circles, up and down, and then the curved surface. And this one here, 2 pi RH, this is the area of the curved surface, and 2 pi r squared is the area of the two circles, the bottom circle and the topmost circle, which covers the cylinder. And from there, they say that area is fixed. But we know very well that to get the volume of anything, most of the times H will be we can use this area to find h, like to express it in to get h, because they say that area is fixed. So we use this formula of total surface area, and we make h the subject. As you are seeing, area equals to 2 pi r h plus 2 pi r squared. Then we make the h the subject by taking this 2 pi r squared, this side, and we divide through by 2 pi r, as you have seen. Then we never defined what volume was, and we said so we must define it that let V be the volume of the what? Of the cylinder. V equals to pi r squared h. We know very well that to get the volume of anything, you get it is base area times height. And here we have the base area of a cylinder is in circular form, and that's pi r squared, and h is the height. To get the volume of anything, we get base area times 8. That's why you have said that pi r squared, that's the circle, the bottom circle, and h, the height. But we know very well our height from this part, from here up, that h from the cross-section area, that h equals to a minus 2 pi r squared over 2r. Then from there we substitute in this one that v equals to pi r squared into bracket area minus 2 pi r squared over 2 pi r. This one has replaced h, as we have seen. But coming back to our scenario, they say that he intends to determine the dimensions of the container that will hold the greatest volume of the nutrients. But another thing which they say is that the bacterial that a cylindrical container with a fixed area, with a fixed surface area. That means that if we are to differentiate, area will be fixed. We can treat it as a constant. Then we go to another slide. We continue. Then from there, they say that the greatest volume. So we have to differentiate with respect to R, because we have removed out area is constant. They say that the question area of the cylinder is constant, but the volume can change. So to differentiate the volume with respect to R, area equals to 6 pi r squared over 2 by reducing the power by 1 on R, because we are differentiating with respect to R. But we know very well that at greatest volume, for greatest volume, the R equals to 0. So we have to substitute this 0 into this upper part of the presentation. Then from there, we come here. So here we have to make area the subject. We have to make A the subject because we don't have it, but it is said to be fixed. At greatest volume, the area will be fixed, but so we take this, multiply both sides by 2, we get 0. Then we take this 6 pi r squared on the right hand side. As you see, we make area the subject, area equals to 6 pi r squared. But from here we have made area the subject. We know that area equals to 6 pi r squared at greatest volume. but we have to they say that we determine the dimensions of the cylindrical container that will hold the greatest volume of nutrients. The dimensions, we know very well that the dimensions of a cylinder, we have the height of the cylinder and the radius of the cylinder. That means that we have to get the height of the cylinder H, and the radius of the cylinder. And we know very well that from here we make R the subject from this expression at greatest volume. We make R the subject, so it will be A from this one, from A equals to 6 pi R squared. Then we divide both sides by 6. Then we get the square root on both sides, and we come up with this expression here. But from here, we say that A equals to 6 pi R squared. A minus 6 pi R squared over 2 equals to 0. And we made the area the subject. And we say that area equals to 6 pi R squared. So from this area equals to 6 pi R squared, we had to bring in R equals to root 2 area over 6 pi. And we put where there is A, we replace with 6 pi R squared. As we are seeing, area equals to 6 pi R squared. That means that H equals to A minus 2 pi R squared. Here we have finished to get the area. From here, we can substitute in for 6 pi R squared to get R. Then for H, where there is area, we replace there with 6 pi R squared. Then minus 2 pi R squared over 2 pi R. We know very well that these ones have the same. They have the same pi R squared minus 6 pi R squared minus 2 pi R squared. They are the same. That means that we can what? We can just subtract them. We get 4 pi R squared. We get 4 pi R squared. Then we divide through, we cross this pi with this one, this pi goes with this one, then this 2 reduces 4 to 2, and then this R will become, this R squared will be divided by this R to become H equals to 2 pi R, 2R. Then on our conclusion, we say that therefore the radius is R equals to root area over 6 pi, and H is A, and H equals to 2R. Let me call on my fellow to discuss the next part, if in case there is no any question.
Good morning, everyone. My name is Wesa Wycliffe, a student, Rona College Maige, Senior 6. So I'm here to take you through the equation, which is number 9, part C. Because we didn't express the equation because master said that everyone received the equation. So here, number 9, it had a part of grace, which is calibrating a spherical culture flask. The intended radius is 10 centimeters, but the manufactured flask has a radius of 9.8 centimeters. Meaning this grace is in need of making a flask, but you don't want to use the radius, which is that one of a manufactured flask. So you need to change that R. So in changing that R, meaning there will be a smaller change. After identifying that one, that there is a smaller change. So here, according to the laboratory quality standards, the percentage error in the volume should not exceed 8%. So we are given a condition that the percentage error which should be expressed should not exceed 8%, meaning we need to find the percentage error in the volume, because when we are changing the radius of the flask,
meaning the volume will also change. So here we are going to use the idea of smaller changes, whereby we need to find the percentage error in radius, and even also we need to find the percentage error in volume. So in some cases, we are not given the volume, the letters which represents or what, we need to first let. So here, he said that he intends he intends to change the radius, which is of 10 centimeters. So meaning, initially it is 9.8, but it's going to change that radius to 10 centimeters, meaning there will be smaller change. So I have come up with here by letting my volume to be V of the sphere, and the R to be the radius of the sphere of the flask, and the small change in V and small change in R. Small change in V and small change in R to be the errors in radius and volume respectively. Meaning, I'm in need of getting small change in R and small change in V. So, getting that small change in R, meaning there will be a small difference between the intended value and the radius of the obtained. So here, the intended value is always greater than the manufactured value of the radius, so of the flask. So here I'm going to get the intended value. I subtract it with the radius. So after doing that, here the intended value, in the equation it is 10, meaning I get 10 minus 9.8, which gives me 0.2. But for any error to occur, we know that to get an error is when to get the percentage error in that radius, we need to find the percentage error using this formula, whereby we have the error, the percentage error is got by the error we have got here. We divide it with the intended value and multiply by 100 because we need to express it in percentage. So, but I have my error as 0.2, meaning I'm getting this is 0.2. I divide it with 10 and I multiply by 100%. So after that, what am I in need of? I'm in need of getting the percentage error in the radius, not in the volume. So I get my small change in R as I get my percentage error as as 2%, meaning I made here a mistake. So it is 2% here. So here, after getting that small change in R be 2%, as you are seeing here, then I can continue because this is a sphere and the volume of a sphere is always 4/3 pi R cubed. This is the method we use to get the volume of a sphere. So small change here, since we want to get the small change in R, meaning I must use this expression to get the V, the R, whereby there was small change in V and small change in R. So I get this expression, I differentiate in terms of one letter which is here. But I'm seeing one letter which is R, meaning I will get the V and the V, the R. because I'm saying here R. So divide R is equal to 4 over 3. This is 4 over 3. Then I reduce, because in the differentiation, we reduce the power of the data we are differentiating by by 1. Meaning here, this 3 will be minus 2, minus 1 to get this 2. So this 2, and we drop this power, which is, so this one will come here, and in coming here, it will reduce with this 3. So it will be 4, meaning remaining here, coming this side. So, and this pi, but I have reduced this r to 2. So it was r power 3, now it is r squared. So I continue, I have got my dv dr, but I know that this expression I have got does not go beyond a bigger value. So meaning this small change in this dv dr linearly changes with small change in v over small change in r. So this one means that this expression means that the value we have got here is beyond this, is beyond this one, but with a smaller value. So we use this symbol to show that it is linearly approximating to this value. So when I make here small change in v, the subject, because I'm winning of small change in v, when I'm when I'm looking for small change in v, I make it the subject. So I make a small change in v, the subject, whereby this small change in r will come this side, or by multiplying both sides by small change in r, even this side small change in r. So I will come up with small change in v to be approximated to small divide r small change in r. So I must make sure that this expression here I'm having, the denominator here must correspond with the value I have multiplied here. So small change in v, small change in v now becomes, but I have this dv dr and I have this dr. So this small change in r is this one, and the dv dr is this one. So I substitute it here, getting this expression. After getting that, now I continue and say that small change in v, because I have this one, the small change in v, now I have got this one in the small change in v. So, but I needed the percentage error of volume, meaning this one, and at first it was, at first I rated this one to be the small change, the error in radius. So here I come up with the formula, which I'm going to use this one to get my small change in v. So that small change in v will now become, I'm in need of getting the percentage error in what? Small change in, I'm in need of getting small change in the percentage error in radius. So I come up here in volume. So here it will be the percentage, the small change in volume all over the volume of the flask, whereby I'm having this small change in V as this small change in V. I've got it as 80 per tubed percent, and this V will be this. So I'm saying that this one is crossing with this, and even this pi go with this pi. So here, this 4 reduces this one to 2, and I'm having here a 3, but it is 1 over 3. When I'm have 1 over 3, and I'm dividing 2 over that, this one becomes automatically a 6. So I'm getting this small change in V, this one, small change in V over small change over V as the 6%. But when we come back to the equation, they say that the percentage error in volume should not exceed 8%. And I'm getting here the small change in volume all over the exact value of volume would to be 6%, meaning this one satisfies the what? This one satisfies, because here the task was like they wanted to establish whether Grace's spherical flask satisfied the laboratory quality standards, meaning this one being 6%, and it should not exceed, meaning it is less than or equal to 8%, meaning this value is less than but not equal, but it being less than satisfied the condition. So, and you conclude here that since the percentage error in volume is less than 8%, then Grace's spherical flask satisfied the laboratory quality standards. So that was part C of the question. So we have finished presenting our work for number 9. So we allow questions about that question. Any question, please?
Okay, we are going to thank you so much, Arena College. Let's start with Top Times High School unmute, then Impoma Girls.
Yeah, my question is about how have you found yes?
Go on.
Yeah. My question is about how have you placed R in the percentage error in radius?
Pardon, because we are not hearing it properly.
While finding the percentage error in radius, we got 2%, but while substituting it in small increment in V, you multiply by 2R%.
So on number C,
Yes.
this expression
Yes.
of small change
That
in
R.
R,
Yes,
this
that
one.
R. Yes.
So when we go back here, so here it was like this because
So we gotten the small the error in the radius as 0.2. Then we gotten the percentage error in the radius as error over the intended value times 100%, and we ended up with 2%. So this implies that the smaller change
in the radius over the exact value of the radius, which is now r, is equal to 2%. So from mathematical expressions, I can get the value of the small change in r in terms of the percentage r and the exact value. So I'll get small change in r as, where is it? I get now the smaller change in r as 2% of r, and if I substitute here the value of r, which is 10, I can get 2 over 100 times 10, which is 0.2. So it's the same thing.
Another question?
Any other question?
Angel?
Excuse me, sir. My
Excuse
question was the first discusser where it started from integrating. I need to know where integration started from because it was differentiation, then he brought that concept of integration. Then my question is from differentiation, why did we went exactly to integration? Thank you.
why did you
Okay,
use?
okay, I've got you. Here we formed the differential equation. Now from here, when you look at this differential equation, because we have the n dt is equal to 5n. So here we solve it by separating variables. We bring the variables which resemble, we bring them together. So this one which has n and this n, we bring them together by dividing n on both sides. So we get the n over n. And this t, we bring it this way. So there we have separated the variable n and variable t, we have separated them. And if we form an equation of such a kind, before bringing these integration signs, after separating those variables, then we introduce these integration signs to integrate. Now, from our knowledge of integration, this is like 1 over n, the n. So when we integrate it, we shall get ln of n, natural logarithm of n. And this one, 5 dt, shall get 5t, then plus c. There we shall have solved this differential equation like this. Have I
Okay,
answered
thank
it?
you. Yes, thank you very much.
Okay.
Okay, lastly, Mpoma.
My concern is about the height. Because here, the final is saying height equals 2r. And if we are to go back to the height, here our height from up here it was h equals to a minus 2 pi r squared out of 2 pi r. But you came and concluded and say h equals to 2r.
Okay, I've got you. So here the height. When we stated the formula for area, total surface area, we made the height the subject, and we got this as our height. Now, after getting because here in this expression, area is constant, it does not change, but radius changes. Here, once we get the value of radius, from when we got it, it is root of a over 6 pi. Now, when you bring this value in the expression for r, we shall, okay,
From greatest volume. From greatest volume here, when we differentiate the V, the R, and we got the greatest volume. At greatest volume, the V, the R equals to 0, as you are seeing here. Here, that the V, the R equals to what? To 0. And from there, that means that at greatest volume, when the V, the R equals to 0, we can make this A to be the subject. So we multiply both sides by this 2, and it goes this side. Any number 2 times 0 is what? Is 0. Then we make A the subject. But from the same expression, this same expression, this one, we can make R the subject. We can make this R the subject, that one. We can make it the subject by taking this A, the other side, this side, and then dividing through by what? By 6 pi, by 6 pi, so that we come up with this one here. From there, we can get square root on both sides, so that we get R equals to what? Equals to root A, so that we get R equals to root A over 6 pi. But we know very well that our A from here, our A equals to 6 pi R squared. Then we just bring it in there. We just express it into this formula of R equals to, we substitute in to get the value of R, then we bring in H. Here in H, we say that H equals to A minus 2 pi R squared. Then from here, we know very well the value of A. This A, we got it up. Then if we are to bring in this A, this is A, this one here, it is A. But we have 6 pi R squared. We have 6 pi R squared minus 2 pi R squared. That means that they are the same over 2 pi R. That means that they can be subtracted directly, since all the variables are the same. That means that we get 4 pi R squared if we are to press our calculators. Then we divide it by with this 2 pi R. After dividing it, as we have got here, this is 4 pi R squared over 2 pi R. After dividing, but we are going to divide it with 2 pi R. After dividing it, we get R H equals to 2 pi R. 2R, sorry. 2R. Then R radius, we got it. If you want, you can get it from A equals to 6 pi. From this one here, you put it here. You put it into this expression to get even R. But for the question for the H, it is here. We have seen how we have come up with it. Thank you.
Okay, is that clear?
Okay. I think it is clear. It is clear. Thank you so much, Rena College, for that presentation. I'm going to share my screen. I'm going to be sharing my screen here. Now, the item that Rena College has been handling, this is the item that they have been doing. But I want to keep emphasizing that whenever you receive the item, one of the things that I want you always to do is identify from this particular scenario that I'm handling, what is the concept I'm dealing with and which method am I going to use. Now, I've told that for whatever scenario you are going to do, there are going to be clues that you must always look out for. And whenever you are starting scenarios, I want to bring to your attention most so scenarios in calculus, scenarios in algebra, and all the scenarios. Never use variables without defining them. That is the first step. Define what you are going to use. Any letter, any alphabetic letter you are going to use those variables, ensure that you define them. Now, when you read through this scenario, I would expect that you are going to first highlight that Sarah is investigating the growth of a bacteria culture that initially contains. Now, you are going to define your variables. That let, I want you to take note that you are going to say that let A equals to the number of bacteria at time t. Now, please take note. What does it mean? It means that in this scenario, wherever we shall have n, it is the same as the number of bacteria at time t. Sometimes some of you write, let n represent this. So, avoid using the word representing something, because when you make your mathematical calculations and you get an equal number, it means that now that one is just a representation. So I will always encourage that, say let n equals to the number of bacteria present at that time t. Now, when you find these words, because when we are scoring, we look at the ability of a learner to translate the mathematical words into symbols. So I want you always to have your summary. Initially contains 100 bacteria. Now, I will expect that you are going to come here and write your initial condition, and you say initial condition. Now, you break the scenario. You say initial condition and write n, and then you say this is 0 equals to 100. Now, that's what we call the initial condition. So we shall be looking out for where is the mathematical interpretation, where is the identification of where is the child converting these words into the mathematics. Then when you continue, note that the rate of increase of the bacteria population. Now that is another clue. Whenever you find the rate, now rate comes from the word ratio. It means that you are going to write something in a ratio form, A out of something. That is the meaning. However, many times when we are using rate, we are referring to T, that the ratio is going to be with respect to time. So when you are dealing with this, now you know that the rate of increase. Now that is another clue that you need to know. Now when you see the rate of increase of bacteria, then the concept that comes to your mind is what you call differential equation. Now that is the concept you have identified. Now if you want, you can go on and be more specific that there is an increase. That means that there is growth of bacteria. Then you need to know that that is an exponential growth. And then you read the mathematics proportional, meaning that now you need to know that the proportional sign is written like how? Like that. To the number of bacteria present, and this is what you call your n. Now we shall still expect to see that mathematics extracted from the scenario and write for us that the n, the t is proportional to the number of bacteria present. Now this is the mathematics we are going to look out for. Has the child been able to identify, to extract the words from the scenario into mathematics? Then we shall expect. Then when you continue, during one experiment, the proportionality constant was found to be 5. Now, I know here when you are removing your proportionality constant, you are going to write the n dt is equal to kn. Now, please define where k is equal to the proportionality constant. And therefore here you can come, after defining what k is, then you can come and comfortably say that now my k is equal to 5 per hour. Now that is very, very crucial. 5 per hour, 5 bacteria per hour. Next time they may not even put for you the word proportionality constant, and they'll tell you that the constant rate of 5 per hour. Then you need to know, hey, that is the proportionality constant. Then when you continue, they have given you what you call the threshold time, which is reaches 10,000. Now that's what we call the threshold time. Now, after you breaking your scenario like that, then make sure that anything you have identified from the scenario here, any word you have been able to obtain from the scenario, put it into the mathematics. Put it into the mathematics, and anything you have written for the mathematics you have written, put it there. Put it there in your work. Never use a pencil that maybe I'm highlighting this and make sure that you put the work there. And now we shall award you with what we call identification. Identification, that ability to convert the words into the mathematics. So that's what we shall be calling the identification. So make sure that when you are dealing with that, extract the mathematics, define all the variables. Like I've said that I want you to start putting subtitles. I want you to start going on to do what? To write the concept that you are dealing with. Now, when you reach here to solving this kind of equation, then you can say using now which method are you using? Like I've said that identify the concept, identify the method you are going to use. And now when you look here, you notice that this is separation of variables. Then say separating of variables. Then you separate them and you show that this is going to be n is equal to k dt. Then from here, and some of you sometimes you want to have shortcuts. Do you know the shortcuts you do? Now for you, because you know already the concept, when you reach here, you just you just integrate there and there. And then this step that you have used, because remember, your first step is going to be the n dt is equal to maybe k. Now here k was given as 5n for that case. Now, some of you always want to come here and just say, now this is separation of variables. You indicate that using the method of separation of variables, and then you come here, you can, depending on what you want, then show clearly this step that now you have separated the variables, the n's are on their own, the t's are on their own. Then you go on and you do your integration, but avoid doing the integration from this step here, where you have separated the variables, because when we are looking out, we shall be looking out, did this child separate the variables? Is it identified somewhere? If it's not there and then you came just here, then that one you may have challenges. So do not avoid those shortcuts. Always sure have this method for separation of variables, and then after there integrate, bring in your natural log, bring in and differentiate, and then also show the constant of integration, and then now you can continue. Now when it comes to still differential equations, I want you to let you know that there are very many applications of differential equations. When they are setting the scenario, a scenario can come from the area of population growth. A scenario can come from temperature changes. The scenario can come from the drugs while people do take the medicine. It can come from forensic science. It can come from economics and business. It can come from physics and emotion, can come from engineering. Now, all these ones are application where the scenario or about differential equation can come from. Now, you need to understand that if the scenario is from this field, how am I going to deal with? But the most important thing, always make sure you understand what are differential equations. Whenever you find that this equation involves a variable, this expression involves one or more two derivatives, and look at the clues. The clues in the scenario should be able to tell you when you find things like rate of change, rate of growth, rate of decrease, then that one is an indicator that you are going to be dealing with something concerning differential equations. Then when you are dealing with this item, please identify what is the dependent and what is the independent variable. Then you go on and ask yourself, from this item, what are those things that are changing? Is it the growth of bacteria? Is it the growth of the population with the time? Because you know that whenever something is growing, also time is moving. So now you need to identify what is the independent, what is the dependent variable. Then keep asking yourself, is it an exponential growth? Is it an exponential decay? And you need to know that when it is a growth that is exponential, then you need to know which areas, what kind of clues are you going to find? You are going to find some things that are going to be showing you the different things. So you need to be very, very careful, and also you need to look at at the what? At the hints that are always given whenever you meet those scenarios. Then when you continue here, they are telling you that when you look at the second paragraph, and whenever you find this paragraph, know that always there is a transition, that maybe this was one concept and now this one may be another concept but related. Now here I want you to define the variables. Don't just come and start using R. R may mean something different. Don't just come and start using H. Don't just come and start using V without defining them. If the scenario has not defined them, define them very well. Where possible, I want you also to make that simple sketch. Go on and make that simple sketch. Now here they were talking about a cylindrical container with a fixed area. So a student could come and say that now I'm going to have my cylindrical container. I will have my cylindrical, write a subheading there that this is a cylindrical container. And now you come, you make your sketch of how a cylindrical container looks like, maybe something like that. Then like I've said, you define where H is the height of the cylinder. You define where R is the radius of the cylinder, where V is the volume. And then when you're finding your surface area, avoid abbreviating SA. What does S stand for? Then write it in full, that now I'm looking at surface area. And now here, if you have defined what R is the radius of the cylinder, of the cylindrical container, where H is the height of the cylindrical container, then you can come and say now, the surface area of a cylinder. And always be very careful. Sometimes they can tell you it is an open cylinder. Sometimes you find it is a closed cylinder. And now sometimes even they may not mention is it open or closed, but you have to think, because if you leave these bacteria when it is an open cylinder, they can escape. Now you need to know that through logic that now that is a closed what? A closed cylinder. And you know very well when you are getting the area of a closed cylinder, it comes from this from the net. This is the net. So you have to be very careful that this is a circle, the area of a circle is pi r squared. This is the second circle, which is pi r squared. This is the top part, and this is the bottom part. So this is like the bottom, and this is the top. Then you know that when you fold a cylinder here, this one is the distance around it, which we call the circumference. So that means that from here up to here is the circumference of a circle, which is given by 2 pi r, and now this is its height. Now you need to know that if it is a closed cylinder, I'm going to be adding the area of this circle, which is pi r squared, plus this figure is a rectangle, and the rectangle, you know, you get length times width, which is 2 pi r h, then plus the bottom, which is pi r squared. And therefore you'll end up with the 2 pi r squared plus the 2 pi r h. Next time they may tell you it is an open cylinder. Now if it is open, it means that it does not have a cover like the cups you use at home, like those open containers where you take your juice, meaning that now for such a case you are going to remove one of the what? You are going to have a figure of this nature, whereby now this is your 2 pi r and this is your h, and then you'll have just one circle at the bottom, which is pi r squared. Now for such, when you are finding its surface area, then I will expect that now you're going to come and set is pi r squared, then plus 2 pi r h. Now do not cram the formulas. No, how does the formula come about? How does this formula come into existence? So now that is what you need. Now after you understanding, you need to go back. You need to go back and then ask yourself that from this scenario, what concept are they looking out for? So when you read through, they told that the bacteria using a cylindrical container with a fixed surface area. That was a clue that showed you that you are going to be looking at a cylinder and you are going to be looking at the area. Do you know those things? Then you go on. The mathematics, they want you to find the dimensions. Now, when they talk about dimensions, we are looking at the length, we are looking at the height, we are looking at the width. Those are the dimensions for the container that they want you to obtain. The height, they want you to obtain the radius of that particular container. But they went on and said that the greatest volume. Now, when you see the word greatest, then you need to know which mathematics is there, that this is optimization, this is maximization, and then you take a note that now here I'm going to be looking at optimization, maximization. Which topic which topic did we cover this? That was under differentiation. Then you need to know that now here some of the things I'm going to apply, I'm going to be differentiating concepts, I'm going to be differentiating something. Now when you go from here, you look at the next paragraph that now is calibrating a spherical culture flask. Now you need to know that now here they are bringing in the issues of sphere. Now you need to remember, hey, if it is sphere, what do I need to look out for? Then you continue and say that the intended radius is this. Then that one should give you a hint that now those are smaller changes. Those are small changes. And then from there, you make a conclusion. Now, whenever they give you these threshold values, things to compare with, whenever you are making your conclusion, dear students, in your conclusion, in your interpretation, or in your decision, have these values, justify with the values. Look at the value you have obtained that I've got 6%. I've got this particular what? Value. So when you are making a conclusion, you write for us a conclusion, that this is the conclusion, and then say maybe therefore the obtained value, the percentage error is 6%. The obtained percentage error is 6%, which is less than the 8%, and therefore it does not exceed the what, the percentage, the 8%. Give us the reason, give the justification, use the value you have obtained, you compare it, make that comparison with the one that is in the scenario. So after obtaining, I'm going to take you that whenever you obtain whenever you obtain, make sure that the first you go back to the scenario and you make the justification. So I want to make you to make it clear that always understand the scenario, identify the concepts within the scenario, select the best approach or the method to use, obtain your accurate output. And many times some of you stop here at the accurate output, that you have got your 6% as let me say the percentage, and you think you have passed. You have to go on and say, have I interpreted the scenario? Have I obtained have I made a decision? Have I made the conclusion? A complete scenario response is the mathematics, the interpretation, and the decision. That's what we call a complete scenario response. So make sure that after obtaining your accurate answer, interpret basing on what is in the scenario, compare with the values in the scenario with the ones you have obtained, and then conclude and justify or make a decision. Sometimes they may want you to make recommendations, so you make a recommendation basing on that. So that is what you need to do whenever you receive. That's when you are going to receive the maximum output or the maximum mark on a given scenario. Allow me now to invite Seseme girls. I don't know which one you are using, Seseme, to take us through another presentation. Seseme? Seseme, you can unmute. Seseme girls, I'm failing to get you. Kindly unmute. Okay, I think Seseme, I don't know whether the teacher is away. Oh, Seseme, We're failing to get you. Okay, I think we have failed to get Seseme. Now I'm going to first invite Rena College to come back with the second number.
Hello?
Yes,
We are ready?
Seseme? Okay.
Yes, we are ready. Give us a moment, like one minute. 1 minute, we are coming. Hello?
Yes, please.
Yes, 1 minute, we are coming. Yes, we are ready. Hello?
Yes, yes. Now, as you are approaching,
We are approaching. Yes, yes. 20 seconds, I've reached.
okay. For those who have just joined, kindly you
I've reached.
can check.
I've reached.
You
Hello?
can check in the chat.
Yes, we are there. We are there. Stop shouting for us.
You can check in the chat. The
Yes, we are
items
there.
have been. Okay. Can we have the phone in landscape format? Landscape. Oh, teacher, can we have the phone in landscape? Okay. So, okay,
Yes.
because better. Okay, we are going to start.
Yes, good morning, everyone. So, I'm from Sesame Girls. My name is Women Rebecca, and we are going to do item 15. And the question says, the National Environment Monitoring Agent is investigating whether the maximum daytime temperature can be predict the concentration of a particular air pollutant in a major city. During the investigation, environmental officers recorded the maximum daytime temperatures and the corresponding pollutant concentrations over several days, as shown in the table below. Yes, you're seeing the table. You have the questions. Then below the table, we have, according to the Environmental Monitoring Department, the proposed temperature-based pollution monitoring system will only be adopted if the relationship between maximum daytime temperature and the pollutant concentration is sufficiently strong to support the reliable prediction. The previous environmental studies indicate that the maximum daytime temperature is normally distributed with a mean of 22 degrees Celsius and a standard deviation of 3 degrees Celsius. The agent reviews its advisory whenever the probability that the maximum daytime temperature exceeds 25 degrees Celsius is greater than 30%. In addition, unusual weather patterns are investigated whenever the probability that the total maximum temperatures recorded over the 5 random selected days is less than 10 degrees Celsius, exceeding 10%. Thus, assist the Environmental Monitoring Department to Part A, determine whether the proposed temperature-based pollution monitoring system is suitable for adoption. Then Part B, establish whether the agent should, 1, review its advisory and investigate the unusual weather patterns. So, Here, this question is about rank correlation. And so we are going to do the rankings of the maximum. We have the maximum temperature and the amount of correlation. So we have the table. We have maximum temperature. Yes, we are going to rank. We have maximum temperature. So on maximum temperature, we are going to call it X. Then the amount of pollutants, we call it Y. We are going to rank for X. Then we rank for Y, representing amount of pollutants, Y. And so we are going to rank maximum temperatures, and we begin with the highest temperature. So on the maximum temperatures, we have 24 as the first, then we have 22 as the second, then we have 20 as the third, we have 18 as the fourth, we have 16 as the fifth, we have 14 as the sixth, we have 12 as 7, then we have 10 as the 8. So then we have it as 8, then 12 we have it as the 7, we have 14 as the 6, we have 16 as the 5th, we have 18 as the 4th, we have 20 as the 3rd, we have 22 as the 2nd, then we have 24 as the 1st. Then ranking for Y, the first one is the 513 is the 6th, 475 is the 8th, 425 is the 2nd, 530 is the 1st, 516 is the 5th, then 520 is the 4th, 520 is the 507 is the 7th, then 521 is the 3rd. So we are going to look for D, which is got by subtracting the ranking of X minus the ranking of Y. It doesn't depend which one you use. So if you want, you can get this one minus this, or you get this one minus this one. So if we get Rx minus Ry, so it will be 8 minus 2, which is 2, 7 minus 8, negative 1, 6 minus 2, we have 4, then 5 minus 1, we have 4, 4 minus 5, we have negative 1, 3 minus 4, we have negative 1, 7 minus 7, 2 minus 7, we have negative 5, then 1 minus 3, we have negative 2. So we are going to look for this squared. We are going to look for this squared. Here so here it will be 2 squared, which is 4. Then negative 1, we have 1. 4 squared, we have 16. 4 squared, we have 16 also. Negative 1 squared, we have 1. Negative 1 squared, we have 1. Then negative 5, you have 25. Then negative 2, we will have 4. So we have the formula for Spearman rank correlation. The formula is 1 minus 6 summation of d squared over n into n squared minus 1. But this one is always in bracket. Then we have this, the summation of d squared will be this one plus this. We are going to add the values of this column. So we are going to get 4 plus 1 plus 16 plus 16 plus 1 plus 1 plus 25 plus 4. So if you add, we shall get 68. Will be 1 minus 6 times this 68 as the summation of this square. This is 68 over any we have 1, 2, 3, 4, 5, 6, 7, 8. So then any will be 8 pairs. So we are going to get 8 into 8 squared minus 1. Which is, this one is always in brackets to prevent errors. So we shall get 1 minus, we calculate 6 times 6 to 8. We are getting 408 over 8 into 64 minus 1. We are going to get 1 minus 408 divided by, so this one, 64 minus 1 is 63. So we are going to get 63 times 8. We are getting 504. You put bracket, then it will become 1 minus 408 divided by 404. 408 divided by 400 by 504. 408 divided by 504. We are getting 0.8095 if you round off. So we are going to get, in order to get our answer, Spearman is equal to 1 minus 0.8095. Our answer is 0.19048. So in the question, we had below the table, we have that according to the environmental monitoring department, the proposed temperature-based population monitoring system will only be adopted if the relationship between the maximum daytime temperature and the pollutant concentration is significantly strong to support reliable prediction. So in order to see if the relationship between the maximum daytime temperature and the pollutant concentration is sufficiently strong, we are going to use the log table. We are going to use the periodic table. If you have periodic tables, we are going to use them. We are going to check on page 58. Then since we have 8 pairs, we saw that any is 8 pairs. So we are going to go on that page 57. Then we check on the first column, of this table. Then we go down. When we reach on 8, we consider that horizontal line. Then we have a column that have the Spearman's rank correlation coefficient. So below it, we have significance if at 5%, then we have at 1%. So between those two percentages, you consider only one. So if we consider to use 5%, we have that on the horizontal axis, where there is 8, at 5% we have 0.71. So since at first we had got as the Spearman's as 0.19048, and in the table we have 0.71. So we are going to comment on the answers that we are getting, so as to see if we shall get the significant strong data. So we are getting and we had got this one. Then in the table we have 0.71, and this one that we have got is less than the one we have got in the log table. So we have 0.71, and that one is 0.19048, and it is less. So in order to get it as a significant, or to get it as sufficiently strong, it's when the wrong correlation that you have calculated. So we are going to compare using this that we have calculated and the one that we have got in the period in this log table. So since we are going to comment that since Spearman equals 0.19048 is less than 0.71, we are using at 5%. So at 5%, for 8 pairs, because we have 8 pairs.
So Seme?
It means that so in the question they were asking if the relationship between the maximum daytime temperature and the pollutant concentration is significantly strong to support the reliable prediction. So here we have
Yeah. Can we first look at someone is asking whether the summation is correct? Can we first cross-check the summation? Very well.
The summation.
Make cross-check and see.
Yes,
yes, the summation for this squared is correct. It is 68.
Okay.
So here the basic, since the Spearman is 0.919048 less than 0.71 at 5% for 8 pairs, it means it is not significant. So we are going to use what we have been given in the question, because they are asking us to see if the relationship is sufficiently strong. So if what we have got is less than what is in the log table, that means it is not significantly strong. It is not sufficiently strong. So on part A, we were asked to determine whether the proposed temperature-based population. We were asked to determine whether the proposed temperature-based pollution monitoring system is suitable for adoption. And in the question, they had said that if the relationship between the maximum daytime temperature and the pollution and the pollutant concentration is significantly strong to support the reliable prediction. So here that means if we have got it as it is not significantly, it is not sufficiently strong, that means the conclusion here will be that the proposed temperature-based pollution monitoring system is not suitable for adoption.
Okay. Can we first have some questions? Yes, I'm seeing some questions coming in. I want to first find out from Madonna High. Madonna High, unmute. Oh, Madonna High is not. Yes? Madonna ask. I don't know. I'm trying to get Madonna, Ian Greenway, and then Mayanja Joseph.
Yeah, so sorry for the inconvenience. Can you please go back to the table? I have a question is concerning on the table there. On the table where you have drawn the rank of, where you have calculated. So I was asking a question like you never ranked this variable which you indicated like R, X, you never ranked his positions, and also RY, you never ranked the position. I wanted to know why. Like you have not included it. In case you are carrying out rank correlation, like I was asking why you have not included that ranking position of those variables.
So at first, because I think all of you have the questions, I ranked it from the table that we have. That's why I went directly to the questions, to the rankings. I had ranked it, we ranked it from the paper that we have. So we had maximum temperatures, and when we are ranking, we rank the first as the highest temperature. And here the highest temperature was 24. We ranked it as 1. Then 22 was the second, 20 was the third, 18 was the fourth, 16 was the fifth, then 14 was the sixth, 12 was the seventh, and 10 was the eighth. So on the amount of pollutants, which is Y, the highest amount of pollutants, we got it as 530. The second one was 525. The third one was 521. The fourth one was 520, and the fifth one was 516. The sixth one was 513. The seventh was 507 and the 8 was 475. And so here on the conclusion of part A, we're going to conclude.
Excuse me, sir. Excuse me, madam.
Here we are going to conclude that the proposed temperature-based pollution monitoring system is not suitable for adoption. The proposed temperature-based
We had a question. Madam, excuse us.
is suitable for adoption. For adoption. Is not suitable for adoption. This is the conclusion for part A. So this was part A. And we are going for part B.
So, Seme, can we have some 2 questions? There is a school that wants to ask. Kindly ask.
Yes, you can ask.
Madam. For us, we
Go
are
on and
requesting.
ask.
For us, we are requesting to more explanation how you have used the logo book to get that correlation.
So here when we were ranking, we had 8 pairs. So we had 8 pairs, and so when you have calculated the correlation, so you go on this page 57 in the log table, in the log book, and then you first go on the column that contains the number of pairs. Then you go down depending on the number of pairs that you have. So in this case, we have 8 pairs, and so you're going to move down until you reach on 8. So when you reach on 8, you consider that horizontal line that contains the values that are corresponding with 8 as the number of pairs. So we used Spearman's rank correlation in this our question, and so we are going to consider. So if you want, you can consider at 5% here, or you consider at 1%. So if we consider at 5% here, so if you go down, if you go across this horizontal line that contains the values that are corresponding with this 8, so at 5% we have 0.71. Then at 1% we have 0.86. So in these two, this 0.71 and 0.86, you consider one of them. So if you want, you can consider at 5%, or you consider at 1%. So when you're concluding, or when you're giving out the conclusion, you first talk about what you have got. Then you see if it is greater or equal to or less than the one that is in the logbook. So we considered in this our question, we considered at 5%, where we have 0.71, and in the question that we had been given, we had got the correlation as this one, 0.19048. So if you consider this one and the other one we have got on at 5%. At 5% we have got as 0.71. So and this one is less than 0.71. So if you get the one that you have calculated and you find that it is less than the one that is in the logbook, that means it is not significant or it is not sufficiently strong. And again, if you get what you have calculated and it is greater than the one that you have got in the logbook, that means it will be significant. Yes, that is how you use the log table. So we are going for part B. So on part B, so the first paragraph, the table and the paragraph that was below, the information have answered part A. So the following paragraphs are going to answer part B. So we have previous, in the question we have that previous environmental studies indicate that maximum daytime temperature is normally distributed with mean of 22 degrees Celsius. So that means we have new meaning mean. Yes, we have mean, which is 22 degrees Celsius. Then we have standard deviation. Standard deviation, if you want, you can use SD, which is, we have 3 degrees Celsius. Then they are saying that the agency reveals its heat advisory whenever the probability that the maximum daytime temperature exceeds 25 degrees Celsius is greater than 30%. Then, so here we have the maximum daytime temperature exceeding 25 degrees Celsius is greater than 30%. So we have exceed, and exceed means greater than. Then we have 30%, which will be 30 over 100. So here they are saying that there is normal distribution. And we know that in normal distribution, we standardize. So we have probability of X greater than 25 degrees Celsius. They are saying that it should be greater than 30%. Then we have, in addition, unusual weather patterns are investigated whenever the probability that the total maximum temperatures recorded over 5 randomly selected days is less than 10 degrees Celsius exceeds 10%. So here we have probability of X less than 10 degrees Celsius. So since they are talking about normal distribution, then we have the mean, we have the SD, which is the standard deviation, So on this part B, where they are asking that establish whether the agency should review its hit advisory and investigate the unusual weather patterns. So we are going to, so since it is normal distribution, we are going to first standardize. So if we standardize this one, which is probability of x greater than 25, so by standardizing it will be probability of x greater than 25 equaling to, when we are standardizing, in the place where there is x, we substitute z. So it will be probability of z greater than 25 minus mu over Stephens. Then so we are going to have probability of z greater than 25 minus, we have mu. This mean stands for mu. Can stand for mu. It can even stand for x bar. So in this case, we are going to consider this mu in our formula. So we have mu as this 22. Then this second stands for standard deviation, and we have it as 3. So we are going to have probability of z greater than 25 minus 22 is 3. 3 divided by 3 is 1. So we have 25 minus 22, which is 3, over 3. So we're going to have probability of z. We have probability of z greater than 1. So on this question, we are going to draw a sketch. So we are going to sketch. Then here we always have 0. Then here we have phi of z. Then here we have z. The values from here to here are always
Seseme? Seseme? Seseme girls? Are we losing out on Seseme? Okay, let's give them a few minutes. I'm going to request the participants that there is a point that missed in the value. So that value would have been 22.5, not 225. So we are going to consider it as 222.5. When you look at that paragraph, it was a typing error. It's supposed to be 22.5. So that's what I wanted Seseme to make the correction. So you can make the corrections on that 22.5. Seseme? Okay, let's give them a few minutes as they get back. Sesame, are you back? Okay. Sesame girls, if you can take us back to the board. I'm seeing the camera is facing the children. Okay. So let's give them a few minutes. Sesame, we are waiting for you. You can take us back to the blackboard. Okay. I think we have. Okay. I think we are failing to get them back, but allow me now to share my screen, and I want to bring to your attention two things. Now, looking at the item, at what they did for the first part, let's give them time as I talk about item 15. Now, when you look at item 15, it required you to do some mathematics. I'm going to share my screen. Okay, now this is item 15. That's Sesame, that's the students of Sesame girls have been doing. Now, when you read through the item very well, there are two things you need to identify. Like we said, always identify what is the concept in the scenario. Now, when you look at it, there are some hints they have given you in the scenario. When you look at things like relationship between something, now that one will give you a hint on what aspect are you going to use. That now here what has to come into your mind, that there is something concerning the correlation. But then you ask yourself, which kind of correlation am I going to use? Am I going to use Spearman? Am I going to use the Kendo Tau approach? Now, it depends on you which approach you want to use. But I want to bring it to your attention that the suitability of the two approaches, the Spearman and the Kendo, depends on the data set. It depends on how many data sets do you have. Whenever you have larger data sets, please always use Spearman. Whenever you find that the data sets you have are many, then you go on and use Spearman. If the data set, if the sample is a small sample, then Kendo would have been the best to use for the particular case. If you find that the sample space, the sample data is really very small, then you can go on and use the sample. Number two, the areas that I want you always to observe is that define what you are using. Avoid ranking from the table. You come and you say, now from my table, this is number one, this is maybe number two, this is number three, number four. At the end of the day, you are going to remain with this what? With this particular paper. Presentation of work is paramount, is very important. So I do expect that when you are going to do your ranking, when you are going to do your ranking, there is you may not tell us that it is ascending, there is no problem. I want you to have a simple title that this is maybe depending on what the scenario is, because the scenario was telling you about the pollutant concentration, then you can say a table or a spearman table showing this and this. Now after that, please define your variables you're using. Don't use x, don't use y if you have not defined. Now like here you say maximum temperature, you put the x such that we know that maximum temperature is the one represented by x. Rank of the temperatures, then you can put rx. Now because I have already defined that maximum temperature is x, here I can use r of temperature to represent rx. Now here you can go on and say now this is the amount of pollutants, and then I go on and say now here I'm going to put y, and then here I can put r of y. Then that's when I can go on and use those different what symbols, but never start using x, using y if you have not defined what those variables stand for. Never use them if you have not defined what they stand for. Then number two, show your ranking very well. Show them you have the maximum temperature and have the ranking. Show the pollutants have the what? The ranking. And then after you do the other mathematics and add. Then I want to let you know that write your formula. The formula is never awarded a mark. However, the marks when they are awarding for the formula, one, they will put correct substitution into the correct formula with correct values. So they look at how have you substituted? Are the values correct? And what about the output? So the formulas, they're not going to give you a mark. They're not going to give you a score. But writing it is okay. Write your formula there. After writing the formula, substitute in the correct values. Let me say now for Spearman, just imagine someone, let me say you have finished to write your formula, and let me say this is you have written 1 minus 6 summation of this squared, sorry, 1 minus 6 this squared, and then you say out of n into n squared minus 1, something like that. And then for you, when you are substituting, you put here minus 6, then times your 68. Instead of n, you put, let me say, 7. Observation, and then here you write 8 squared minus 1. Now here, when you look here, you notice that the formula is okay, but what about the substitution? Do you have your n as 7? Now here you cannot be given a mark because you have substituted in the correct formula but with wrong values. So we look at the correct values substituted in the correct what formula for you to be able to get a right output, and a right output cannot come from a wrong formula. So please take note when you are writing those formulas. In case you miss out, maybe you are not yet sure because of anxiety, then feel free to go back and use your log tables. Then number 2, look at the language used in the scenario. Now, when you look at the language used, they use the word sufficiently strong to support reliable predictions. Now, we have different ways we can interpret probabilities. But before I leave the probability, I want to let you know that whenever you are dealing with any probability, for the case, like for the number we have been, always write to at least 4 decimal places. Never write a probability to less than 4 decimal places. Your decimal places, it should be to 4 decimal places. Now for the answer that they had, I expect that your answer, anything you're going to get in this answer, you are going to write it to 4 decimal places at least, but not below that. So please take note of that whenever you are dealing with the probability, your minimum number of decimal places should be 4. So here I expected you to write 0.190476, and then maybe to 4 decimal places you could stop at 1905. So that is probability. So that is how you can write. But in case the question is talking about in percentages, then you have to convert your probability into percentage and you write to at least 2 decimal places when you are dealing with the percentages. Okay, now when you look at the item, they said sufficiently strong. Now when we are interpreting probabilities, we have what we call the probability scale. And the probability scale can look like this. I can use this in correlation, that we have what we call no correlation or what we call negligible. Now we have what we call weak, very weak. We have what we call weak positive correlation, moderate, strong, and then very strong correlation. Then in case we are going to negatives, also we have these ones that are negative. Now, depending on the value you have obtained. Now, for our case, here we obtained 0.190476. Now here, in case the question was using words like strong, like this and this, then also maintain the same language. Do not change the language the scenario has used. But what do we expect? We expect you to know that if they say sufficiently strong, where does sufficiently strong lie? In case there's correlation. So you can see that correlations that are strong, they are around 0.81. That's what we can call sufficiently strong correlation. And when you look at the one you have obtained, you notice that the one you have obtained is 0.19, which is around here, a bit weak or very weak positive what? Correlation. Now, your comparison you are going to make is going to be in that line, that because you have got a weak correlation, from the value you have got. So you could interpret it that the temperature provided is giving a weak linear, weak positive correlation of maybe 0.19 compared to the other strong one of the other sufficient strong correlation. Therefore, it should not be adopted as a reliable predictor on the evidence alone. Now, that is what you need to do. Now, members, I know that sometimes if this particular scenario you are dealing with, next time it can be in terms of the graph. They can give you a graph. Now you need to know if they have given me a graph, they can give you, and when you are going to compare with the graph, they can give you a scenario whereby they tell you that in a certain year the graph obtained was like this. And now they want you to compare with the results you are obtaining. Now, for such, if the comparison if they have given you a comparison, it means that you need also to do a scatter graph such that you can compare. When you are comparing values, compare values with values, words with words. If it is graphical approach, if they tell you that in 2015, the graph that was obtained looked like this, and now they have this data. Now, that kind of relation comparison, then it should signal you that now there I need a graph. I need to have a graph such that now I know which kind of thing I'm going to have. And therefore, you need to know the description. That if a graph is like this, it means that is a strong positive correlation. If you have an equal number and you have very many points, then you need to know that this is this kind of what? Of graph, that maybe it is strong, it is negative, it is very weak, like that, like that. So always understand the scenario and then respond in line with the scenario. But if this item here that we are dealing with, they had given us a percentage, let me say they had told us a 1% or 5%, something like that, then you need to know that now when I'm comparing and I'm coming up with either I can have a 1% significance or 5% significance. Sometimes the question may ask you to compare, let me say in terms of significance. In case here in the question, they had put a word maybe, and the pollutant concentration is significant, something like that. Then there, you need to know that now you are going to use significance. But whenever we are using significance, we have what you call a 1% significance and what you call a 5% significance. Okay, just give me a minute. So when we talk about a significance, we are looking at how much risk are we going to accept. That's what we call a significance. Now, when we are using significance, I want to bring to your attention that whenever you want a stronger evidence for something, then we use what we call a 1%. If you want now something very, very strong, then we use what we call a 1%. But if the significance you are looking out for is not so strong, then that's when we use a 5% significance. Note that you must just use any significance. You use it in case the significance has not been specified. But in your scenario, you read through and they are bringing issues of significance. When it comes to 5%, we use it we use it for moderate or what we call mild situations. When it is 1%, we use it for what we call much stronger evidence. Things that are very risky. If something is very risky and you know that any simple mistake that is being made may result into a very big thing. Let me say, just imagine, just in 200 maybe liters of milk, you put just some small spoon of salt. Now that one is where we use such for high risk things. Let me say in medical world, let me say in drugs, vaccinations, and the rest of that. Now for such things that are very risky, we use a 1% because we don't want to risk. Yes. Now, there we need evidence, evidence that something happens. Now, you need to know when you use 1% and when to use 5%. 1%, we use it for much stronger evidence, where you needed a stronger evidence. But for moderate, mild thresholds, then there we can go in for a 5%. Now, some of you have not used these significance tables, but whenever you get your logo table, always come and say that how many observations do I have? You count the pairs you have. That maybe now for the case that we had different pairs. So you count how many pairs you have. That maybe I have 8 pairs. So you come where there is 8, that 8 is here. Then you highlight this. Highlight this. And then say now, what significance am I comparing? That maybe I'm comparing 5%. Now, for this particular item, since it was moderate things, then that's why they went in for the 5%. But because the item I did not mention the significance, then that was not the best comparison to compare with. Now, when you find that the probability you are getting, like here they are giving 0.71 as the probability, but for you are getting an answer that is, let me say, 0.19. Now you notice that the answer you are getting is less than 0.71. Then there you say it is not significance. Why? Because 0.19 is less than 0.71. So here you say it is not significant at 5%. But if the answer you are obtaining, let me say you have got your answer as maybe 0.9 and you are comparing with the 5% significant, since your answer is of 0.9 is greater than 0.71, then you will say that it is significant at 5%. What does it mean? That the bigger the percentage, when 5% and 1%, 1% you are looking at accuracy. You want to be more accurate. There are things you do in life where you want a high level of accuracy. Now that's the 1%. But if you are not looking so much at the accuracy level there in the moderate, that's when you use the 5%. Now please take note, read the scenario, understand now that this one is being polluting the environment. You know how dangerous it can be. It can be very, very risky for an environment. You are administering drugs and you are comparing how the two drugs are working. Now that one is a very risky situation. You want to attain very high accuracy levels. Now there you go in for 1%. Then, dear students, I understand that sometimes you may go in and then you have maybe issues. Let me say, the formula may go. You may sit in an exam. Before you know it, the formula has gone. Or you may make a mistake. What you do, ask for these logbooks and then you check out for that particular method that you may want or that you may want to remember. You'll find that these ones are there in the logbooks. Then you can remember. But like I've said, now you'll find that Spearman is here, so you'll be able to use it, and then you substitute into the formula that you are working with. So that is basically what I want to say, that always define the variables, have a title, know when to use the 5% and when to use the 1%. 1% is used for things that are 1% is used for risky situations. Those situations, in case anything very, very small is made, you can kill people or something can happen. That's when you use 1% because you want to obtain a very strong evidence for something. Then 5% is used for things that are a bit moderate, not so a bit minor. That's when we use the 5%. I don't know whether Sesame girls are back such that they can continue. Sesame, kindly unmute and tell us whether now we are back. Oh, am I failing to get Sesame girls? Okay, I think okay, I think I'm failing to get okay. They have said unmute us. Okay, Sesame, you can unmute, and then we complete that item. Okay, I'm going to share the logbook here for those who may not have it. Sesame, go on.
We had hit on part B that was asking us to establish whether the agents should review its hit advisory and investigate unusual weather patterns. And I have got the correction. Here there is 22.5. I had made it 25. Let me go.
Time.
We have probability of X greater than 22.5 degrees Celsius. So if we standardize by standardizing, because it is about normal distribution. So when we are standardizing, in place of Z, in place of X, we put Z. So by standardizing, the probability of X will be probability of Z greater than 22.5 minus mu over Stefan's. And I had said that mu means mean and Stefan's means standard deviation. So we have probability of Z greater than 22.5 minus mu, which is this one, 22, divided by standard deviation, which is Stefan's, which is this 3. So we have probability of Z greater than 22.5 minus 22. We have 0.5 over 3, meaning that probability of Z will be greater than 0.5 divided by 3. We have 0.16667. I've rounded off. So here we are going to sketch. So we are going to sketch here we have 0. We have phi of Z. These are X values of X. So we have, it will be Z since we have standardized it. Then we have a critical point as 0.16667 and it is positive. So from here to here, this is the negative side, the positive side. Then that critical value we have is in the positive direction. So we have 0.1667 here. Then the sign is greater. So since it is greater, we shall go this way, this side. And we know that from here, from 0 up to this side, the probability that is there is already 0.5, and from here to here is 0.5. So to get the probability from here to here, we are going to get the probability from here to here, which is 0.5 minus probability from here to here, so that we get from here to here. So we are going to say that probability of Z greater than 0.1667 equal to from here to here, which is 0.5 minus the probability from here to this point. Probability of 0 is Z less 0.167. So here we have 0.5 minus. So we are going to use the calculator. So we are going to use the calculator. We are going to press on mode.
Come say binding.
So we are going to press on mode. You continue pressing until you get SD. Then after getting SD, you press on 1. After pressing on 1, you go on shift. You press on 3. Then you will see P open bracket, Q open bracket, R open bracket. Then you press on Q open bracket. You press 2. Then you put this value that we have here. This one. You place 0.16667. Then you place on equal signs. We are getting 0.066185. Then if we subtract 0.5 minus that one, we are getting 0.433815. So this is the probability of Z probability of is this one, probability of this. So it will be probability of X greater than 22.5. So we have this probability, and in the question they had said, so we had said that in the question they had said that the agent reviews its advisory whenever the probability that the maximum day temperature exceeds 22.5 degrees Celsius is greater than 30%. So we have got the probability, and so we are going to change it to percentages to see if the percentage we are going to get will be greater than, so that we can get the way to advise this agency. So here we have got the probability, so we are going to change it to percentages, which will be 0.433815 multiplied by 100. So we shall get, it will be 0.433815 times 100. So we are getting 43.3815%. And in the question, they had said that the agency reviews its heat advisory whenever the probability that the maximum day temperature exceeds 22.5 degrees Celsius is greater than 30%. So this 43 that we have got is greater than 30%. And so the agency should review its heat advisory because this 43.3815 is greater than 30%. So the conclusion will be the agency should review the heat advisory because 43.815 is greater than 30%. Because 43.3815% is greater than 30%. So this is part one.
Excuse me, Sesame, before we go, I'm going to ask the camera person to let the child show us how to use the calc to obtain that probability. She explained to us, but if you can have the calculator and then she shows us practically. Dear students, follow up how you can use the calculator to obtain. In case you do not have a table, how can you use it?
So we are going to get our calculators. Then we place on the button of mode. Then you're seeing a comp and another, we have comp one, then we have CMPLX, then you again place on mode, continue placing, then you will see SD, reg, base, then you place one for SD. You place one. After placing one, you go on the bottom of shift. Then after you place the button of three. Then you're seeing P open bracket as one. You're seeing two open bracket. Then you place on two. You place two.
Select two.
You place two for two open bracket.
Two.
You place two. Then after that you put
Have we lost them? Okay. So we have lost Sesame, but I know they are going to get back. Yes, dear students, sometimes you may not have the book and then you may get stuck. But always what you do, like she has shown us, always place mode, standardize your calculator. So SD means standardize. So standardize by placing 1. Then from there you place shift and then you place number 3 and then you'll have P, Q and then R. Now depending on the inequality sign you have, in case it is less than, you use 1. In case it is in between, you use 2. In case it is greater than, you use 3. So you place number 1 and then you put in that probability that you have, or that value you have been able to standardize the Z value, and then everything will be very fine. Sesame, are we back? Okay, but
Back.
okay. And using a calculator is a key skill. Many times some of you lose marks because of calculator use. So make sure that you use your calculator very well such that you do not miss out on the on those. You do not make errors on some things that you would have avoided. Yeah. Okay, repeat on when to use P and Q.
We
I've
are
said
back.
that you are back. Sesame, okay. Sesame, go on. With the calculator, first show them that P, Q, and then the R. And when to use them, someone was asking.
Yes, we are going to get our calculators. Then we place on mode. We place on mode. Place again. Then you place on, you have SE, then you place on figure 1 on the calculator.
Okay.
After that, you place on the button of shift. The button of shift. After that, then you place on the button figure 3. Then you place on Q. We have Q. We have P open bracket. We have Q open bracket. Then you're going to place on 2. Then you put the figure that we have at 0.16667. 0.166 is 0.16667. Then answer, you go on equals, and you will get 0.066185.
Continue.
We are going for part B. We are going for Roman 2 for part B. Here we are. establish whether the agency should investigate the unusual weather patterns. So we have another statement in the question that says, in addition, unusual weather patterns are investigated whenever the probability that the total maximum temperatures recorded over 5 random selected days is less than 10.0 degrees Celsius exceeds 10%. So here we have probability of X less than 10 degrees Celsius. So we are going to standardize this one. So by standardizing, we shall have probability of X less than 10 is equal to probability of Z less than 10 minus mu over 7. So we have probability of Z less than 10 minus mu we have 22 degrees Celsius over seconds we have 3. So this will be probability of Z less than 10 minus 22, that is negative 12, divided by negative. Is negative 12 divided by 3. We are going to get probability of Z less than negative 12. So after here, we are going to sketch So we are sketching we have 5Z. Here we have Z value. So we have negative 4. That means this negative 4 will be on the negative side. So we have negative 4. Then we have less. This sign is for less. That means we shall go this side before negative 4. This is the side for less. So we are going to get probability of Z less than negative 4 according to 0.5. From here to here, we have 0.5. Then we are going to look for the probability from here to here. That means we shall get the probability from here to here minus the probability from here to here. So we shall have 0.5 from here to here, which is probability of negative 4 less Z less 0. Here, since we have a negative 4 beginning this expression, we are going to say by symmetry. So probability of negative 4 less Z less 0 will equal to the probability of 0 less Z less 4. So you're doing by symmetry, this negative becomes a positive and it goes to this side, then this 0. It's like, so we are going to bring back this one. So it will be probability of Z less negative 4 equaling to this 0.5 minus this one. Probability of 0 less Z less 4. So this will be 0.5 minus. So we are going to put in the calculator. So we are going to get our calculators. Then you place on mode. You place on mode. You place again. Then after that you are seeing SD. Then you place on the button of 1. Then you go for shift. Then you place on the button 3. 3. Then you're seeing P open bracket. You're seeing 2 open bracket. You're seeing R open bracket. Then we are going to place on 2. When you place on 2, you're seeing 2 open bracket. Then you put the value that we have, which is 4. Then place equal signs.
Okay, it seems we have some issues. So, Seme, do we have issues? Okay. I think when I look through the chat, I'm seeing quite a number of questions coming in. I don't know whether Sesame girls are ready. We can be responding to some of these questions. Starting with Francis, you can unmute.
I'm seeing how to obtain vigilance will give it availability and the action.
Okay, Francis, you can type in the chat your area. There is a lot of background noise. Yiga? Okay, I failed to get Yiga. Kajoba Savior? Okay, I failed to get that. Kajoba Savior? Okay, I failed to get Kajoba. Coach Goma SS? Oh, I'm failing to get people. Mpoma girls.
Yes, you answer. Okay, the question is we want to inquire from you back from correlation. When she was ranking, she used in descending order, but for us we thought you use ascending. She used ascending, and for us we thought you use descending. To rank in Spearman's correlation.
Okay, Mpoma. When you are arranging, you can use any. You can either arrange in ascending or descending order. It does not matter. However, when you are arranging, you follow one pattern. If you have decided to arrange in ascending order, you follow ascending order for both. When you have decided to arrange in descending order, you arrange in descending order. So it doesn't matter. However, make sure you arrange ascending. Don't change the direction. That here you are arranging in ascending, then there you are arranging the descending. So if you decide to use ascending order, arrange everything in ascending order. In case you have decided to arrange things in descending order, then arrange in descending order for both variables. You do not interchange. So what is important is the consistency in what you have used to arrange. So if you are arranging in the ascending order, you can start from the smallest actual value, you give it the first rank, and then you fall. Descending order, you start with the largest actual value, give it the first rank, and then you continue. So whatever approach you use, you get the same answer as long as you are consistent with what rule you have followed. Okay? Lango College. Sesame girls, are you back? Okay.
Okay. I'm just requesting that you help us also you read the probability using mathematical table.
Oh. Okay. Like the probability she had, eh?
Yes.
Okay. What have you
And then,
got? Yes? Did you get any value?
yes.
So what did you get?
Uh, for us, we have got 0.4522 to 4 dp.
Okay.
Even also shifting the Z value after getting the negative value. I thought she was supposed to shift onto the next side after using the symmetry.
Come again?
When the Z value was got to be -4, after using the symmetry, she was supposed to draw another curve with the positive value on the other side and shift the positive.
Shift the negative to the positive side by symmetry.
Which you are you talking about the last part she was doing or the other first part or the part she has been doing now?
The last
The
part.
last part she was doing now.
Oh, okay. I think I wanted to look at their board, if they could share their board. Seseme, Seseme, if you can unmute and share with us your board. Oh,
Lastly,
come again?
lastly,
Yes.
we would also like that you re-echo on how to read the values of correlation from the table, how you did it. Because our connection was jamming, so we would like that you repeat it again so that we get it clearly.
Which values?
How to read the correlation values from the table.
From the logbook.
From the logbook.
Okay. Okay.
Yeah.
Let Sesame finish, then I'll get back. Sesame, can you continue? Yes?
You write for him the message.
No, Sesame, I can hear you. Okay. I think we are failing to get Sesame. But I think they are going to get back and then we shall finish. We shall finish unless there is a school. Let me ask Rena College.
Mister,
Yes, please.
in a question you are given, in a question you are given that in addition, unusual weather patterns are investigated, whether the probability that the total maximum temperatures recorded over 5 randomly selected days is less than 100 exceeds 10%. When they were making the solution, they didn't indicate anywhere 5. And do I use that 5 or not? And if not, why do they give us that 5?
Okay. I want to first hear from Seseme. Seseme, if you can respond to that. Oh, I think I'm failing to get Sesame. In case there is any school that did that part, kindly place for us in the chat such that we can give you an opportunity to do it. But I want to bring to your attention that the 5 days, ON was 5, and you were supposed to use it when you are calculating your probability. Okay, but I think we have failed to get Sesame girls. So we are going to give them an opportunity. When they get back, uh, we shall continue with that part. But for those who did it, I want you to check that you have around 6.8, 6.81, and then you can compare it to your value. So okay, they are saying, oh, Sesame, you can unmute.
Okay,
You can
we are now.
unmute. Okay.
It's okay.
So Sesame, the first question you had was that there was 5 that was given. Was that 5 useless or it had to be used?
I'm not seeing 5 in the question.
Like it was saying that in addition, unusual weather patterns the total maximum temperature recorded over 5 randomly selected days.
We're doing that. This week. So pardon the question.
You pardon the question.
I'm saying that when you read through the question, the second paragraph, it had some concept. So we want schools wanted to know whether that 5, the 5 randomly selected days, it was useless to have it there or it had an impact. I think have you seen?
Speaking line, I'm not understanding. Okay, yes, pardon. Answer the question.
So here we considered the temperature that we were given as 10 degrees Celsius. So as to see if we shall get the percentage that exceeds 10%. That's why I never used these 5 randomly selected days. So we had reached here and we had put in the calculator, we had got this answer. So if we subtract 0.5, if we get 0.5 minus 0.49997, we are getting 0.0003. And in the question, they had said, in addition, the unusual weather patterns are investigated whenever the probability that the total maximum temperatures recorded over 5 randomly selected days is less than 10.0 degrees Celsius exceeds 10%. So this probability is going to be expressed in percentages so that we get to know if the percentage that we shall get will exceed this 10% in the question, so that we can get the way to conclude for this Roman. So we are going to get 0.00003. We multiply it by 100. So as to get the percentage. So if you multiply by 100, we are getting 0.0003. 3%. And in the question, they are saying that the probability that we shall get, they are saying that the weather patterns are investigated whenever the probability that the total maximum temperatures recorded over the 5 randomly selected days is less than 10 degrees Celsius exceeds 10%. And so here we have got 0.03%, and in the question they are telling us to see if the percentage that we shall get will exceed 10%. And according to what we have calculated, the percentage that we have got is less than 10%. And so we are going to conclude conclusion. So they were asking us to establish whether the agents should investigate the unusual weather patterns. So if the percentage that we have got here is greater than 10%, we would conclude that the investigation for unusual weather patterns should take place. But here we have got it as less than 10%. So we are going to say that the agency should not investigate the unusual weather patterns and we put the reason. This is because the calculated probability is less than 10%.
Should I put it this side?
So this is the end of the question that I had been given. My name is Wimana Rebecca from Sesemega.
Okay, thank you so much, Sesame Girls. We are going to first have some few questions, and then I'll come in. Okay. Mother Kevin ask. Mother Kevin, unmute and ask. Okay.
Yeah. Yes, good afternoon to you all. Thank you for the opportunity granted. I'm Akro Peter from Mother Kevin Comprehensive. What I wanted to find out is that our presenter Rebecca from Sesame wrote our Z values to 5 DPs in the first one. Now I wanted to find out the specific number of DPs that we are supposed to write the Z values so that we are aware of it, because at a certain point she wrote some for when they are in 5 DPs, then the other one when they have no DPs. So specifically, how many DPs are we supposed to write the Z values? Thank you.
Sesame. Sesame, respond. Okay. I'm going to respond at once. But those when you are using a logbook or the UNEP tables, you write them to 4 decimal places. A calculator gives to 5. So that's why always it is important you specify whether you have used a calculator or you have used a UNEB table. UNEB table, you'll find them to 4 decimal places. So you stick to the four decimal places. For the calculator, it gives to 5, so you can write to 5. But like we said, probabilities always write to at least 4 decimal places. The more the number of decimal places, the more accurate you are. Cityland College Matuga. Cityland College Matuga. Okay, we have failed to get you. Then lastly, Kabalega Masindi. Okay, I think I've also, yes?
For me, what I was asking, what I wanted to inquire from that lady is that why was she only relying on using 5 and maybe R, but first was only relying on using.
So, Seme, could we have a response? Okay. I think I've failed to get Sesame. Yeah. Is Sesame back? Okay. Now, there is a school that asked us that they did not pick how they got their probabilities. Sesame, are you responding?
Hello?
Yes, please.
Are you getting us?
Yes, please go on. Are you responding back?
Pardon the question.
The question was that why were you using pi?
5.
Yes.
So we are using 5 because on the sketch there is a sketch that we have there on the board where we have phi of z, and in place of that z, it's where we put the value. That's why I was using phi, that phi of which phi, that phi that it looks like 2. Then in place of that z, I was placing there the value that we were given. That's why we were placing on 2 where there is phi z.
Okay. 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 Thank you, Sesame, for that presentation. I want to start from there. I'm going to start from there. Now, dear students, like I have told you already, that when you are reading now for the schools that were asking about the probability tables, always look at the number of observations you have received. If the observations you have received, let me say you find that the pairs you have are 8 or they are 13, or is, let me use 13. Look here, and then you make a comparison. However, when you are looking here, I want you, oh, sorry. So look here always. I want you to check out that we have two things. We have what we call product moment coefficient of correlation, and we have what we call the Spearman Rankers correlation. Now the calculations you are making are under the Spearman is correlation. So you come here. Let me say it was 8. Come and check here under the Spearman. Then if the value you get, let me say at 5%, you have got a value like 0.98. This value you have obtained is greater than this value for Spearman, which is 0.71. Therefore, something will be significant. So you say that 0.9 is greater than 0.71 at 5%. Therefore, it is significant, like that. Then in case you are using candle, then still you do the same. In case you have used candle and you get your value above 0.64, then you say that the value I've obtained is greater than 0.64, then therefore it is significant. Now that is what you use. But please pay attention that we have what called Spearman and we have what we call the candle tau approach. But always you use them depending on the data. Always when it comes to candle, it is applicable where the data sets are few, where the pairs are few. But if you have very many pairs, then there you cannot use candle. You go in for Spearman. Candle is accurate, but when it comes to large data sets, it's not accurate. So I would advise that whenever you see your pairs are going above 12, then don't use on or don't go on to use what? Candle. There, the best approach to use is Spearman. Then in number 2, I think now that is clear. Then number 2, I want to share again the slides here. When you are using a calculator, for probabilities, a calculator will give you values that are 5 depending on what you have placed, but it will give you values that are above. So what do you do? Now I want you to take note that what is, oh sorry, it is here, that when it comes to a calculator, things are a bit different. I want you need to know the probabilities and when to use a particular letter. Note that all times you are going to use a what? You are going to use. So when you are using this first one, the P is when your Z value is greater. Let me say you have your probability of Z and you have remained with, let me say 0.1434. Now here, once you have such and you place on your calculator, you are going to get 1434 and then you will get your answer. Now here your calculator will give you 0.55701. And when you are using a calculator, then you don't subtract minus 0.5 until you are adding 0.5. There you don't do it. You take it directly the way it is. In case your probability is, let me say probability of 0.41, maybe less than Z, less than 0.5 for something like that. Then for such is when you use your Q. But also if you have your probabilities in this kind of format, like after you have subtracted 0.5, you have said 0.5 minus 0 less than Z less than 0. Maybe 41, then that one is very okay. You can as well use the Q. That's why when Sesame was presenting, they used that middle value. Then in case you have your probabilities and your probability is Z greater than maybe 0.142. If it is such, then that's when you use your Q. Your R, the last probability. 0.142, and therefore this is 0.142, and therefore you'll get your value as 0.44354. So a calculator will give you 5 values, and you indicate that I've used the what? A calculator. In case you're using the log tables, for them they strictly write the probabilities to 4 decimal places. But for the calculator, it can give you 5, it can give you 4. But for a calculator, you feel free always try to at least 5 decimal places. That is for the calculator. Then for the last part, I'm going to invite each one of you to go back and review that part. The part that was telling us that in addition, unusual weather patterns are investigated whenever the probability that the total maximum temperature recorded over 5 randomly selected days is less than 100 degrees. I want you to make your calculations. Make sure you utilize that the number of days, the 5 days that have been indicated. Now, those 5 days, it does one. It changes the mean of the sum. Then number 2, also it changes the spread of the standard deviation. So your standard deviation, the way it spreads is going to be changed. So when you are making your calculations, you have to utilize that the five days. So you make your calculations. I'm not going to be able to go through it now because we have many items, but you look out for the value close to 6.81 around there. So that is what you are going to do. Okay, thank you. So I want now to invite, I'm seeing some hands. I'm going to invite, I don't know whether Rena College, you are still there. You do for us one item. And then there is another school that wanted, those who are asking how we placed on the calculator, kindly, I think we say that go to where you have mode, place mode. First standardize your calculator by placing one where you have found the
Okay. Share. You got to minimize that, minimize the screen, minimize. Yes. Minimize. Backup, okay. Very good. Okay, good afternoon, everyone. I'm Kadaya Hamfred from Rena College, Mayuge, presenting item number 10. First of all, is everyone getting me? Are you hearing me?
Yes.
Okay, that's good. So this item is, they are saying, a newly established beverage manufacturing company is evaluating the performance of a new production line before committing additional investment. The market analysts have developed a mathematical model relating the rate of change of the company's accumulated profit to the time t in months after production begins. The rate of change of the accumulated profit is modeled by this expression. They are saying this expression is the PDT is equal to 5 minus t out of t squared minus 5t plus 6. Now here, they added on. where P represents the accumulated profit in millions of shillings, and T is greater than or equal to 0. At the beginning of operations, T is equal to 0. The company's accumulated profit was 8 million Uganda shillings. So if we they are saying the board of directors requires the accumulated profit after the first 4 months and the total increase in the accumulated profit during the same period to evaluate the performance of the new production line. The company will approve the proposed expansion only if the accumulated profit after the first 4 months has increased by at least 80% of its initial value, and the increase in accumulated profit during the same period is at least 7 million Uganda shillings. And we are handling the task. So when you go to the task, when you go to the task is saying using appropriate calculations, determine whether the performance of the new production line satisfies the company's investment policy. Now, if we have to analyze this scenario, we are going to evaluate the company's investment policy, but we should base on the conditions given in the scenario. They said these people have developed a mathematical model. This mathematical model relating the rate of change of the company's accumulated profit to the time T in months after production begins. Now, what does that mean? This is the model they have given us. The PDT is equal to 5, like you are seeing there. So here, it was a plus down. Here it was a plus. So it was T squared plus 5T plus 6. Yeah, it was a plus here. I've corrected it. Those who have the scenario, you can see properly. It is a plus. So now, this is the model. And they are saying P represent the accumulated profit in millions of shillings. So our calculations, what are we going to start with? They have given us so they have said the P is the accumulated profit in millions of shillings, and the T is we have let T be the time in months after production begins, as they have given us in the scenario. So they have given us this expression, and when T must be greater than or equal to 0. So we should first get the what is P. We should get the expression for P, the accumulated profit. So we should use integration. So if this is a differential equation, and we should solve it by separating variables, we should bring dt on the right hand side, so that here remains with dp only. And on integrating both sides, we shall integrate p we shall integrate dp. We shall integrate dp, and the other side we integrate the other expression. This was an error. So we are integrating dp. And the other side we're integrating this expression. So here, this is so here, integral of dp, this is not there, is equal to the other. Now this expression on the right, we are splitting it. We want, when we look at this scenario here, they have given us an expression down the denominator. So we shall solve it by integrating using partial fraction. By partial fraction. So by partial fraction, we should split this expression into partial fractions. So you should factorize it, and we should get two values. When we add them, we get 5, and when we multiply, we get 6. And those are 3 and 2. That's why we have said, that's why we have, the values are 2 and 3. So here we should factorize. Now when we factorize it, we shall get this expression down. T plus 2 into t plus 3. So here let us first focus on this expression down. This expression, we let this expression be equal to the partial fractions, where the numerators are a and b. So then from there, now from there, this expression, we are splitting it into partial fractions. So here we shall, find the constants a and b. So now, when we find the constants a and b, we calculate them by letting let me check here. So we shall let that expression, this expression here this expression 5 minus t over t plus 2 plus 3 is equal, is equivalent to a over t plus 2 plus b over t plus 3. And since this is the LCM, we can multiply it throughout on both sides, and we get, when we multiply it on the right, it will cancel, and we remain with 5 minus t equal to a. Now, when we multiply it by this fraction, so here we have equivalent, and we shall have a into t plus 3 plus b into t plus 2. Then we want to get the value of A. This means we should eliminate this B by letting T be equal to -2, such that we place here -2. It will take away this 2 and it becomes 0. So we'll get the value of A. So we shall get the value of A. So the value of A will be let me check here. The value of A, as you are seeing, we have got 7. We have got 7. So when you want to get the value of B from this expression, the value of B, we should substitute when T is 3. When it is -3, we shall be eliminating A, and we remain with B, such that B we can get -8. And then after getting these constants, we substitute them into our original fractions, which we had let to be A and B. So we put 7 and 8, and these are our new fractions. So we now integrate on the right and on the left. So integrate these partial fractions independently, such that when you integrate dp, we get p. And when you integrate 7 over t plus 2, we shall see that from our knowledge of integration, this 7 can be pulled out and we have 1 over t plus 2. And when you differentiate this down, it will give us 1, so we shall have 7 ln of t plus 2 after integrating. And the same, when you integrate this one, we shall get 8 ln of t plus 3. Now, plus a constant c, which is the constant of integration, or the arbitrary constant. Then, as we proceed, remember, we have just got an expression for T, for P, which is the accumulated profit. Now, what will it help us? It will help us in fulfilling these conditions which are in the scenario. When you go back to the scenario, it was stated that when you got back to the scenario, they said at T is greater than or equal to 0, the profit was 8 million. So if we go back to our expression, we should find the constant C. And we where there is T, we put 0. When you substitute 0 here and here, we shall get the real expression, which does not have the constant C. And remember the company, it's here. When you put 0 and the 8 million, which were there initially, we shall be getting the value of C, as we are seeing. We shall get 8 is equal to 7 ln of 2 minus 8 ln of 3 plus C. And we shall get our C as 11.9369 as the value of C. Now, as we proceed, after getting the value of C, we should use this value of C. We should get this expression. This is our new expression of the accumulated profit. Now, in the scenario, they said they want to get after 4 months. It requires us to get the value of the accumulated profit after 4 months. As you are seeing here, the board of directors requires the accumulated profit after the first 4 months to increase in accumulated profit. The board of directors requires the accumulated profit after the first 4 months. So we should find it. So if we go back to our expression and we substitute the value of t, which is 4. So at t is equal to 4, we are saying that when you put here 4, here 4, in this expression, we shall get the accumulated profit as 8.9119 millions. This is the accumulated profit after the 4 months. So they asked also for the increase. So from our scenario, we shall see that they are also asking for the increase in accumulated profit during the same period. When we go back to our expression, we have got the profit after the 4 months is this one, the accumulated profit. So we get the increase. We should get this new accumulated profit minus the initial. So when we subtract, we shall get 0.9119 millions as the increase in the accumulated profit. Now, from our scenario, what are they asking else? We should get, they said, the company will approve the proposed expansion only if the profit after the first 4 months has increased by at least 80% of its initial value. So we should determine whether our increase is at least 80% of the initial. So let us go back to our expression still, and we see whether it is 80% of the initial. So the percentage increase in accumulated profit, which we have got here, we get this increase over the initial value, which was 8, as they have told us from the scenario, then you multiply it by 100%. So when we compute, we get 11.1% as the percentage, 11.4% as our increase, percentage increase. Now, if after getting this 11.4, what will it help us? So we go back to the scenario and see what are they asking. They said the company will approve the proposed expansion only if the profit after the first 4 months has increased by at least 80%. So if it has increased by at least 80%, it means the company will approve the proposed expansion. So, and they said, and increase in accumulated profit during the same period is at least 7 million. So if these two conditions are approved, if these conditions are achieved, the company will approve the expansion. But when we look at our answers, have the conditions been obtained? So the percentage we are seeing, it is 11.4, which is less than the 80% which is required. So we are saying the percentage is low. The percentage increase is low. So this condition does not satisfy the condition in the scenario. And when you observe this increase also is less than the 7 millions which they asked for in the scenario. Therefore, we concluded that the performance of the new production line does not satisfy. It does not satisfy the company's expansion, because the increase in accumulated profit for first 4 months is less than the required value, the 7 million, and is less than 80%, because this is a percentage. So 80%. It means we concluded that the performance of the new production line does not satisfy the company's investment, because the increase in accumulated profit for first 4 months is less than 80%, and the increase in accumulated profit during the same period is not 7 million. So therefore, this it does not work. It will not solve the company's production plans. So that's our presentation for this item. I think you've got something from there, and anyone who has a question you can ask. Thank you for listening. Any
Thank you
questions?
so much, Rena College. We have Tabasoma, unmute. Amoria Secondary, unmute. Ariana. Kindly go on and ask.
I also want to know
Go on. Oh, I think we are failing to get people. Ariana? Mike?
Yes. Good afternoon.
Yes, good afternoon to you.
Thank you. Mine is just an inquiry concerning that part of the differential question where we first scroll down. Okay. I wanted to know where that 11.9 something came from, but I got it. It was C. That part jumped me. It escaped me. So, okay, thank you.
Okay, Dixon.
Kumbe safari constant of professional kidogo. Si do.
Okay. Continental College. Continental College. Okay, I think I've failed to get them. Okay, I think I have failed to get those people. I'm going to share my screen, and then I have a few things that I'm going to put across. Okay, thank you once again for sharing, Rena College. That was a question from our curriculars. So it was testing for the partial fractions. It was testing for your knowledge of integration, how you can integrate natural logs. That was the major area that it was testing for, and you need to be well conversant with some of those things. Allow me now to share my screen, and then I'll have a few things to put across. Now, those who came in late, you found us when I had already taken you through the structure of this paper, how the paper can look like. So I think I found us, but now I want to, okay, just a minute. Yes, I want to build up from there. Oh, wait. Yes, I want to build up from here. Now, dear students, as you select the methods you have to use, here I've just placed for you a few of them. In fact, I want to say ETC here and ETC here. Whenever you are attempting an item, kindly specify which method have you selected. In case we are in paper 2, you have read a question, you have understood, specify that using the trapezium rule, using the Newton-Raphson method, using the Bayes' theorem, specify the approach, specify the method. I told you earlier on that the method, it's no longer about you answering, but we want to know which method are you using to manipulate the concept. So make sure that where the method is needed, where you have made a choice, specify that method. That using logarithms, polynomials, factorization, and the rest of that. Mention those particular things and let them be your subtitles for the particular items that you have chosen. Now, I want you to take note that there are a few areas I want to emphasize. Number one, dear students, ensure that you read the task before you make any calculations. Ensure that you have identified what is needed. Before you make a decision that this is the item I want you to go through, this is the item, I want you always to first sit down, identify what is needed in this particular item. Will I be able to do it? So read before you start calculating. Before you start making calculations, ask yourself, what does the question want? How am I going to approach, and what kind of conclusion is needed? So you must be able to respond to the what, why, and how before you start attempting the item. Number 2, extract the mathematical constraints from the item. Now, like you note some of the items, they have used words such as at least, words such as at most, such words such as before, maximum, minimum, within, and the rest of that. Make sure that you extract the mathematical constraints. Avoid just always equating equals. Look at the mathematics inside there such that the right constraints are extracted from the item. Number 3, define your variables clearly. Never start an item if you have not defined the items. If the items have not been defined by the scenario, define them. Don't just come with your x, your y, your t without defining what does that t equal to. What does that t? So a variable should be given a meaning. It should have a meaning, and where units are needed, put the units. Number 4, show your working. Sometimes some of you want to jump steps because you know the procedure. Now that step you are jumping might be the most needed step. Don't jump steps, however fast you may be. Make sure that the steps are not missed. Then use diagrams as mathematical tools. Where, like, let me say those items in geometry, those items they may need a sketch. Have your sketch there. Have the sketch there. have the vector diagram in vectors. You will have a line, have those diagrams there. In mechanics, where you have the projectile paths, have them there. Where you have connected particles, free body diagrams, have all those relationships shown on the diagram. Don't just calculate without having that first diagram, without having that particular diagram. Then we have what called check admissibility. Now, sometimes you are going to be calculating and you are going to come, let me say you are calculating about the time and you have remained with the 20 sine of 30t and maybe this side is greater than maybe 30 point what, something like that. And you find that in your calculations, you are going to get different values of t. And you notice that some of the t values are resulting into negative. Then that's where you have to check. Can time really be negative? Then you know, what do I need to reject? Which roots are extraneous that I need to reject from the calculations? Now that's what we call testing, checking whether this thing makes physical sense, whether this thing is valid or not. When it comes to logarithm, you are going to remain with your values of t of maybe negative 2 and 3. Ask yourself, if you are working with log, can we have a negative log in here? Then you know that no, this value I need to first check it out whether I'm going to continue with it or not. Always check. Then avoid what we call premature approximation. Many times you are, let me say you are dealing with the Newton-Raphson methods and you have got your value of x1. Maybe you have reached 1457 and you are just rounding off to 4 decimal places. Because this value is the continuous value that you are still using to make calculations, always write to as many decimal places as you can. As long as it's not yet the final answer, never terminate, never truncate before you reach the final answer. So make sure that you write here. If they tell you that they want the answer to 5 decimal places, then make sure that here you are carrying 6, 7, 8 decimal places such that your levels of accuracy are high. The more decimal places you write, the more accurate you are going to become. In case here you are making calculations, let me say you have calculated the value of x is 2.11. 114 something like this and continuous, and you are going to use this value in the future, then I will advise always write this in a fraction form such that you are very accurate on your final ending, because the output, the correct output matters, makes more sense and is much needed. Then make sure that you verify, substitute your solutions back to the original equations and check whether they make sense. You are going to find simultaneous equation. Take an example. When you look at item 1 in the seminar questions, you will notice that it's about a simultaneous equation calculation. You first verify, use your calculator, check, is the thing correct? Remember, you have time. So check, is the thing correct or there is a mistake I have made here? If you are dealing with partial fractions, you have made a quadratic equation. First check, is this quadratic equation factored? Because sometimes they can trick you. They bring for you a quadratic equation, and because for you have crammed that every time I meet a quadratic equation, I must use ax plus b. Please check, can that quadratic equation, quadratic expression be factored? Then verify before you continue. Always check your answers. More so for the answers whereby you are still using it. First verify. Don't rush. Don't rush. First check out, is this thing right? Because there are some mistakes you are going to commit which will make all your work wrong because of one mistake. Check whether the lines, now like you're going to find in vectors, where they're going to ask you for point of intersection, where they're going to ask you for the line when 3 planes meet and such things. Always verify before. Now there are some areas where you need to make an assumption openly. Now for such areas, please go on and make that assumption. Make that assumption before you continue, that here let this and this, because sometimes the assumptions that are needed before you make your final thing. Then the other one is always return to the scenario before you make your conclusion, before you write your statement, that conclusion. First return to the scenario. Return to the scenario and then ask yourself, from the scenario, a strong conclusion is going to have a computed output, then a comparison with a criterion, or what we call the threshold, or what we call you have to compare in case they have given you some values, and then after you make a decision. That is a good conclusion. Ask yourself, what output have I obtained? Compare that output you have obtained with the criteria they have given you in the scenario. After that, make a decision where need be interpret, where need be go on and make those particular conclusion. Never leave an item without concluding. Even if there, in case you have different parts, part A, part B, make a conclusion here, make a conclusion for part 2. Because we shall put a P application, we shall put this and this. And mind you, I want to let you know that conclusions carry marks, carry heavy weights. A conclusion takes a lot of marks. So never rush and say, I don't want to conclude. You'll find a conclusion. A conclusions always take to a maximum of 3, but you can find a conclusion taking 2, a weight of 2, taking a weight of 1. So never miss those conclusions, and always do not forge. Do not forge, because sometimes we are testing. Can you be able to compare? Then that one will be very okay. So you are going to start seeing, like, when the teachers are scoring you, they are going to be using formulation, they are going to be using manipulation, they are going to be using applications, identification, and analysis, depending on the item and depending on the section where that item is. So you'll find them putting AP31, and then you need to know that I need to separate. And when you are writing your conclusions, in case it is a block item, whereby sometimes they may not give you task A, task B, but it can be one task, whereby the task is just, it can be one task, say, help Martina to do this and the other, help Hannah to do this and the other. Then for that, when you are making your conclusions, make sure that if the conditions are many within the scenario, 1, 2, 3, make a conclusion for the first, make a conclusion for the second, and then make the final one that summarizes everything, such that in case someone is calling your work, you can be able to see the first comparison, because they can give you quite a number of conditions that for this it should be this, for this it should be this, for this it should. So never combine them into one conclusion, but make one conclusion for the first criteria, make the second conclusion for the second one, make a third one, and separate them, such that someone who is scoring your work is clearly visible and is not into one thing. But I want to let you know that during the scoring, there are basically 6 parameters: identification, that ability for you to be able to extract those words into the mathematics. They are going to use application, they are going to use formulation, anywhere where you are going to be using a formula. And I told you that in a formula, when they are scoring, we look at the formula, but we do not give you a mark. However, we check out, has this child been able to write to use the formula well? Has she substituted in well? Are the values inside the formula good? What about the output? Those are the things we are going to be looking at. Now, I want you to avoid spotting topics. Some of you are good at spotting. Even some of you might have spotted already, may have said, me, I'm going to do this, me, I'm going to do not spot. We still have a lot of time. There's nothing like spotting. Sit down and then read everything. Read everything that you have, most of all the compulsory items. For the compulsory, make sure that everything is within the head. Now, where I've talked about defining the variables and where units are needed, please put the units. You may have noticed that for item 2, you had units of meters, centimeters, put the units. I have talked about premature approximation. I have talked about unverified results and solutions. Then when it comes to trigonometry, make sure that you read your angles very well. Sometimes they will give you a domain, but indirectly, and now for you need to know that if the angles are negative, which direction? Do not forget to draw these diagrams. You draw them and show clearly where your angles are. Do not shy away because you want to calculate. Because everything you are doing, please do not cram, put them there on your paper. When it comes to to reporting a statistic item, make sure that you interpret, you make a report basing on what the scenario has asked for. Then avoid double counting of forces and end every number. Make sure that you have made a decision. Make sure that you have made a conclusion. Now, when it comes to paper 2, I want you always make sure that your approximations are always compared to the threshold before making a decision. Then for numerical method, you should be able to know the formula, the iteration, and then the error criterion. Now, sometimes when you are writing the percentage error, I want you always do not forget to put the magnitude. The use of the magnitude, that in case you have got any negative, in case there is any negative, you get a positive. But also it shows an understanding that your percentage error can never be what? A negative. That's why you always have the magnitude in there. When you are writing a natural log, I'm writing a natural log maybe of x. Because this x can take on a positive and negative value, please clearly indicate that natural logs, we can never have a negative. So the use of putting a natural log there is to show that you can never have a negative. When it comes to statistics, ensure that you interpret it depending on the context. Don't look at the output you have obtained and then you make the policy or the rule or the decision basing on what you have been given. When it comes to the mechanics items, force diagrams are very key, and make sure that when you are representing the forces, let me say you have drawn your diagram very well, you show clearly. Let me say you have got negative 2i plus 4j, and these are newtons. Clearly show. And when you are drawing these diagrams, please make sure that there is the mathematical sense. If it is negative 2 plus 4j and you are making a sketch for the first diagram, please, we need to be realistic that here, and you cannot tell me, you cannot put here 2 and then you come here and maybe you put here 4. Please, that one can't, because when you look at this, you notice that 2 and 4, they cannot be the same magnitude as forces. So clearly show that there is a difference between a 2 force and there is a difference between a 4 Newton, a Newton force. One is stronger than the other depending on the direction. Then make sure that your sketch diagrams are correct. If you are drawing negative 2i, let me say 3i, then maybe 2j, then we expect that you know that this is a positive force, it will move like this. Once it reaches there, it will take on, and then after you will come and show us the magnitude. So distinguish between what the magnitude, the resultant force is, and the other forces that are not resultant. Clearly indicate the angles, that this is where the angle is or this is where the angle is, depending on the what you are finding out. Never forget the arrows on force diagrams. You just coming up with this one, you are not going to be scored, because a force is a vector quantity. So we expect to have the magnitude, we expect to have the what? The direction. So clearly indicate and make sure that your sketches are working sketches and are correct sketches. Avoid just drawing. Let me say, in case maybe you had negative 2i plus 4j and someone came and had something like this. This is wrong, because this doesn't represent this kind of what? Of force or this kind of vector. Make sure that the sketch you are drawing is a working sketch, is well labeled, and clearly shows the kind of direction the vectors are taking. Now, I want to bring to your attention that items would ask you that use an approximation method. Now, we have very many approximation methods, but the syllabus will specify, will be specific, because we have some that we want. Now, when it comes to approximation methods, I want to let you know that in numerical analysis, we have very many you are going to find. But you need to know, what does that approximation method do? That is now the understanding, such that you know clearly that if the scenario is talking about this, then what I must click is that here it needs me to do this. Now, whenever you are using an approximation method, let me say it is trapezium rule. Trapezium rule is basically used when you are estimating areas or accumulated quantities. That's when we use the trapezium rule. So whenever you read the item and you notice that the item is about areas, it is about those things of areas, about cross-section area, then the approximation method that should click, that one they are testing for trapezium rule. Trapezium rule is for areas, and we use the trapeziums to estimate those areas. So like take an example, estimating the cross-section area of a river of this and this and this. So now you need to know when I'm going to use a particular approximation method, under what conditions, and what are those clues that I must look out for such that I can be able to use that method. Now that is trapezium rule. The moment you see area in your item, then you know that the method for finding area is going to be the trapezium rule. Then we have what we call the iterative methods. Now, when it comes to estimating the roots, estimating unknown solutions, estimating things such as radius of a tank, depth of an excavation, unknown temperature, break even, equilibrium, unknown engineering, then that means that you are looking for iterative method. Now, for you, the moment you read and you say that they want to install at this depth, then you know that, now this is iterative what? Method. Then you remember, what are those iterative methods? That is the Newton-Raphson method. And then it brings and it clicks very, very fast. So you read the question and then you know that here, even a thing that involves finding the unknown, radius, depth, height, timber, what, then you know that that is iterative methods that you need to use. In summary, I want to bring to your attention that trapezium rules will be used for estimating areas, accumulated quantities. Iterative method for estimating unknown solutions, roots that cannot be conveniently obtained using the ordinary algebra. Then when it comes to paper 1, you are going to see estimating values of functions that are complicated. Now, when you see such, then you need to know that that one, I'm going to use the Maclaurin series that you cover in senior 6. Then we have also normal approximations. More so here, when you meet probabilities that are very large, that means that you need to remember your continuity correction. You need to remember that now I'm estimating to binomial. More so whenever you find that your sample population is above 20, then you need to come to your mind that here I need a normal approximation approach. When it comes to small changes, whenever it comes to estimating those effect on small change measurements, radius, height, and the rest of that, then you need to know, in case it is square root of things, then you need to know that I'm bringing in the issue of smaller changes. Then when it comes to error analysis, estimating uncertainty. When you look through, you'll notice that there was an item that required you to use maximum and minimum because they wanted you to estimate the uncertainty, how many tents can fit. Then you need to know that now for such, I'm going to bring in the issues of maximum and minimum such that I can be able to make the calculations. So I want you to let you know that please clearly define the variables. Whenever you are making a conclusion, have that decision, have the reason, show you're working clearly where units are needed. Please make sure you do the necessary. And now, please, we need always to plan. I want you to learn how to plan for the paper. Planning. If the paper, your time, remember, is for 3 hours. Now, I want you that for whatever item you are going to obtain, let me say this is item number 1. This is the second item, item 2. And this is maybe item 3. I want you that when you are reading a scenario, each of these items here, dear students, give it a minimum. Let me say this is the first item. I'm going to give it 45 minutes. This is going to take me 45 minutes. And also this one is going to take me 45 minutes. Now, when you add, when you look at my time, I'm just showing you, you notice that I'm going to have other minutes. I'm going to have 45 minutes. This is extra time. I'm going to just put the extra time. I'll tell you why. Now, when I'm planning for the paper, I'm going to first give each item 45 minutes. And I want to let you know, never spend more than 45 minutes when you have not written anything on an item. So what are you going to do? The 45 minutes are for working out the item. But each of the items, I want you always, you spend 5 minutes first understanding highlighting all the mathematics. 5 to 10 minutes, you are highlighting, you are looking out for the math, you are writing the word math into numerical values for the item. Bid for item 2, spend around 5 to 10 minutes. Item 3, spend 5 to 10 minutes. Then you are going to notice that all these different items will not take you 45 minutes. There are those that you are going to do that will take you few minutes, around 30, and you'll be done. There are those that are going to take you more time. Now, these 45 minutes you are having as the extra are the minutes you'll keep adding on the other. And I want to let you know that, dear students, always start with the item you feel you are confident in doing. Whenever you receive your paper, first go through all the items. First check through all the paper. Don't say that item 1 is what I'm supposed to start with. You may read item 1 and it is untouchable. You read it there, you have read the statement, you are not understanding, you are not clicking. You waste time trying to interpret. If you read through for the first 10 minutes, things are not clicking, first ignore it, go to the second item. Look at the second item. If things are not working, go to the third item, such that you can first identify the motivator, the one to start with. Whenever you start with an item that is a motivator, other items become easy with time. So I want you always first make sure that the item you start with is that item you feel you are going to maximize in, such that now you get the motivation to do other items. So plan very well for your time. Don't spend more than 45 minutes on an item. These extra 45 minutes are to help you to cross-check each of the items you have done. That, have I done very well? Haven't I made any mistake? Is this item okay? Is this item okay? Is this item... Please, if you finish before the 3 hours, don't hand in. Don't say, I have finished, let me sleep. Go through now the item, small, slowly, until when everything you feel that everything now is clear. I want to take you back to the topics, because now I want you to plan better as you approach the mocks, as you approach these mocks. Now, when you look at the paper one, I want you to plan very, very well for your paper one. Make sure that when you are planning, I want you to give time. I know you have read, your teachers are completing the syllabus. I want you to go back. As we end this session today, go back and ask yourself, can I be able to look out for the small components in each of the topics? When it comes to, let me use trigonometry as a sample. Now, this is how you are going to revise. That if I'm to handle trigonometry as my topic, I'm going to come and I break trigonometry into small chunks, such that I know what I need to know within trigonometry, such that if you master the concept, scenarios are going to be very easy for you. Then you are going to ask yourself, what are those things within trigonometry that I need to know? Now you'll find out that when it reaches trigonometry, you are going to pull out some few things. One, you need to know what we call trigonometric functions. Then I need to know the identities in trigonometry. I need to know how to solve trigonometric equations. I need to know how to use the R formula. I need to know how to use the T formula. Then I need to know how to sketch the trigonometric functions. Now, the moment you know all those things, it means that now you are okay. That means that now you are a step ahead. That means that now you can do things concerning what? Trigonometry. Do the same in vectors. That in vectors, I need to know how to find the equation of a plane. When I have 3 planes, how do I get a line? When I have 3 planes, how do I get skew lines? And the rest of that. And then that one is your summary. For you, keep ticking. Now, today I've looked at R formula. Today I've looked at T formula. Now I know how to use them. I've looked at how the trigonometric identities, I know how to use them, I know how to prove them. Then go to the second topic, Do the same, that I know now midpoint, I know gradient, I know this and the other. That I know permutations and combinations, I know how to arrange things, I know how to do this. Go to series, I know the APs, I know the GPs, I know their real life applications, like that, like that. Go to partial fractions, summarize that in partial fractions, I need to know the repeated roots, I need to know those roots that are not repeated, I need to know the quadratics and how to deal with them. When it comes to differentiation and integration, please know the different, how to differentiate exponential, how to differentiate natural logs, how to use the integration by parts, how to use separation by variables, how to use this and the other. And then you capture this particular paper. Do the same to the second one. Summarize that now, do I know the trapezium rule? Under what conditions do I need to use the trapezium rule? Some of you, I know, you have already crammed the formula. But next time, members, if you look at this, the scenarios you have, you may have noticed that I was capturing the paper was capturing that if now you are given, when you have a sketch for the cross-section area, do you know how you can apply trapezium rule when they have not given you a function? And then you come up with the answer. Next time they are going to give you a graph and they will ask you to extract the function that has been graphed. Now you need to know that, do I know how to use Newton-Raphson methods? Do I know how to get the errors? Those are the things. When you look at those seminar items, when it came to descriptive statistics, there is something that was hidden from you. When you look at that item, I think let me first share them again because now I don't know whether our time will allow. Okay, let me okay, I think they're here. When you look at this item, very well, you may have noticed that this item, it was asking you for the idea of quartiles. I know you have done upper, lower, and thing. And now even you were just lucky that this particular item here, it was asking you on how to find the quartiles, whereby you need to know now, the quartiles that I have 0, this is the 25%, this is the 50%, and then maybe I have the 75 what? Percent. That's what the question was asking. So you had to compare and know the limits, that under the lower quartile, where do I stop? Because this item wanted you to know the quartile. So we expected that you are going to first find the lower quartile, you find the upper quartile, and then you categorize basing on the what? On the premium, basing on the economy class, and then the standard grade. Now, those are the things that you need to know. That and read the item, understand, and ask yourself, what does the item want me to do and how to attempt it? It's not about now cramming how to use this, but how do you use those particular things. That one is very important. That one is very important. Okay. Okay. Now, that is what you need. Break these items and pack them into small chunks such that things can be very clear. You note that these items can combine 2 topics, so you need to be well conversant. Give them time. Do not make mistakes. I want also to bring to your attention, more so now when it comes to these statistics, when you check out, you may notice that some of these items, let me first stop sharing a bit. Let me first stop sharing for a minute and I get a page. You are going to, when you are reading these items, please know when, because now the statistics, it can appear very easy, but you may mess up, more so when it comes to class limits. Sometimes I know you need to be well conversant because these statistics can be brought in different ways, and you need to know that if it is brought in this way, how do I deal with it? Sometimes they may just give you a class if they love you a lot, they will just give you a class. And now you need to know here, more so when it comes to class boundary. How do I find a class boundary? That this one, since the classes are the same, I will just subtract in minus 0.5. Sometimes they will give you when the classes are like this. Now you need to know, if it is like this, how do I get the class boundary? Next time they are going to give you 10 to 15. I can just give you the classes like this. I tell you that this is a class limit 10 to 15, 15 to 20, and then I put here 20 to 25. Now, because, and I just put here that these are classes. Now, if you find such, you may find a student subtracting to get class boundary. You may find someone subtracting 0.5, 0.5. Dear students, do not cram. Understand. Why do we subtract the 0.5? Why do we add? That one is dependent on what we call the adjustment factors. Now, the moment you check, dear students, and you notice that these ones are the same here, please never subtract your 0.5. Those ones are already class boundaries. So here your class boundary remains 10 to 15, 15 to 20. You don't need to subtract. Next time you are going to find when they have given you class 10, here they will give you 15, they are going to give you 20. Now here to get the class boundary, just say 10 to 15, 15 to 20 and continue. Next time they are going to give you things 10 less than 20 and you are going to say, how do I, and then they put here 20 less than 30. Now here these ones are already class bounded. As long as these two are the same, for you just say 10 to 20, 20 to 30. Next time they can just give you something like this, that less than 10, less than 20, less than 30. Please do not panic. Know that this is the same as 0 to 10, 10 to 20, 20 to 30. Those are your class what? Class boundary. Now always understand how to get class boundary, because that one can pull you. You have seen scenarios whereby they will put you here 10 to 15 and maybe here they just put 20. Then they put another class like here. It should not what? It should not disorganize. Now, how do I deal with this? Is there a mistake and the rest of that? No, that one is never a mistake. So please make sure you revise your statistics very well, such that you are okay. Now, those are some of the things that we need always to look out for when we are dealing with the when we are dealing with the calculations. There are quite a lot of things there, students, that you need to give attention. There are quite a lot of things that you need to pay attention to as you are responding. It's not about finding X, finding Y, finding this and the other, but you need to know the mathematics behind it. You need to know how to deal with them. You need to know how to go about some of those issues. Do not rush to do something, but always make sure that you know the mathematical sense. Make sure that now you can be able to summarize. Make sure that you are able to interpret the scenario, give a conclusion, and then make sense from whatever thing you are making. I'm going to be entertaining a few questions, and then we shall close it from there. I'm going to be entertaining. Give me a minute, and then I am going to uh, me to clarify. Number one, I have seen someone say that I'm saying members, please take note that every section A has one compulsory item. So paper 1 has one compulsory item and also paper 2 has one compulsory items. Yeah, so we don't have two compulsory items in section A. Yes, so every paper has just one compulsory item, and I told that in paper 2 it is numerical analysis, and then in paper 1 is geometry. That is the section that is compulsory. Then the other two items you choose are the optional items. When the class width are different, when you find that the class width are different, depending on what you are calculating, don't forget now to use the frequency density. Whenever you find that the class width is different, here they have given you, let me say, they have given you things like, I can give an example. They have given you a different, I think, let me share my screen. In case they have given you an interval. Let me say they have given you 30 to 39. Another one they have given you 40 to 49. Now you have 50 to 54. You have 55 to 69, something like this. You note that the class width is different. You note that here the class width is different. This is 10, this is 10, this is 5, 50. This is what? This is around maybe 55 to 69. This is 15. Now, if you find that the class width is different, then it means that here you are going to find your frequency density, which is always given by frequency divided by the class width. So that means that is what you are going to use to do your particular things. So you have to pay attention more so if you are going to draw a histogram and you are going to do those things. So make sure that you pay attention to that more so when the class. So you first check out and then you continue. Errors still in paper 2. Yes, errors, though they can cut across because they can give you a threshold in paper 1. When we are resolving forces, do we use the trigonometric direction? Now, when we are resolving forces, let me say you have your force diagrams. Let me say this is the force diagram. I have this is the force. And let me say this force here is 5 newtons. And maybe I have here my angle of 30. Something like that. Then maybe I have another force maybe here. And maybe this is maybe 20 and this is 3. Now, when I'm resolving, let me say this is the force. This is maybe my horizontal component, and then I have the vertical component. In case I'm resolving for the 5 Newton force here, remember this is for this particular angle, this is your opposite, this is your adjacent, and this is your hypotenuse. Now this is your y component, and this is your x what component. Now when I'm resolving this particular force, I have to resolve and get my horizontal component, which is the horizontal component here. Then I get my vertical component what I have here. So this one, you resolve it towards this. This one, you resolve it towards that. However, you look at the direction. Like the direction, this is a positive direction, this is a positive direction, this is the negative direction, and this is the negative direction. So in case your force is resolved and it is pointing this side, like for the 5 Newton, it is pointing in the positive direction. So that means that this force will become 5 cos of 30. When you resolve it vertically here, it becomes 5 sine of 30. Why it becomes sine? Like when you look here, you notice that sine of 30 is equal to opposite, which is y, out of hypotenuse, which is 5. So your y component becomes 5 sine of 30. So your force is going to be pointing upwards, which is a positive direction. But when I'm in this quadrant here, when I resolve my force towards this, here it's going to become this is 3, then it will be sine of 20. But when you look at the direction it is facing this direction of negative, so you'll put negative sine 30. Once I resolve it here, it's going to become 3 cos of free cos of 20. But where is it pointing? Is pointing in the negative direction. So it will be negative. In case I'm in this quadrant and maybe this is my force, maybe 40. Once I resolve it here, it is pointing in the positive. So I will say 40 cos of maybe cos of any. Okay, I will say 4. Let me call it 4. Then cos of 30. Maybe in case this, okay, here I've put 40. Once I resolve it here, it's going to be pointing down and it's going to be negative. So you can understand the directions of the forces when you are resolving basing on that. But you don't need to bring in the idea of quadrants, that this is the quadrant, this is the quadrant, or the idea for the bearing. Now, how many scores are awarded for each item? Each item is awarded differently depending on the weight. Depending on the weight. So we score differently depending on the weight of that item. So you may find that the first item is very heavy, so we score it higher. It is given a bigger weight. So now the scores are not constant. That this one is going to be 20, 20. It will depend on the weight of that particular item. What if the force is exact at the negative x-axis? In case it is here, let me say it is here 5 Newton. Then in case for horizontal force, since it is pointing in the negative, you just take it as negative 5. Since it is pointing the negative, yeah, you take it as negative. In case it is just here, then this is positive because it is pointing this side. Yeah. Okay. Yes, I have told you that Newton numerical analysis is going to be in paper 2. Those first ones were samples from the other. Okay. I think for the rest, I'm just looking through the chart to see whether there are some concerns or some items that I can respond. I'm still looking through the chart. Now, Rena College, I've given an example. I've said that in case you have 10, you have 15, and you have 20, such, and you are finding that for the class boundary, this one will be 10 to 15, this one is going to be 15 to 20, then this one will be 20, this one is going to be 20 to 25. So that's how you can do it. In case it is 10, 20, 30, then you know that it will be 10 to 20, 20 to 30, 30 to 40. That's how you get the class boundary for the last one. When we are given forces and directions, now when you are given, let me say they have given you north 30 degrees east. Now it means that, remember, this is your north line, this is your east line, and this is your west line, and this is the south. So it means that when you are drawing this force that has been given, start always from the north. North, turn 30 degrees, and now this is where we have the east. So you place your force there. So this is going to be 30. And always extract the information from the scenario and put it on the sketch. In case maybe they had given you west, and they say maybe 20, and then they put here south. Come to the west line. The first letter shows you the starting point. 20 turn towards the south, and then you'll put here that this is my force, and then you put the 20 in that position. So that is how you do it. In case now they had given you 330, in case they had given you 330, then you need to know that 330 degrees, we use the bearings. So you come here, you know that how many degrees are these? These are 270 degrees. Then 330 is going to be around here. So this is the 330, but now you measure off, because if this is 270 around this point, then you are going to come and say, now if I have 330, I will say 330 minus 270. So here I'll put 60. So you place your force in here. Yes, the direction of the force matters when you are getting the resultant. So the direction matters when you are getting the. How do you differentiate natural log? Now, when you are differentiating natural log, let me say you have natural log of x. Now, here you need to know what natural log is. Let me say you have. I want you to know that natural log is the same as having log e x. But from your trigonometry, okay, yeah, I can use trigonometry. From your trigonometry, you learned that log of AB is equal to C. You learned that it's the same as BA to C. Now, if I have this kind of log, it means that I can write this as E power y is equal to x. Now, here you need to remember, how do we differentiate exponentials? You know very well that when I have a ddx of an exponential, I will still get that exponential. So when I differentiate this with respect, I can differentiate this side with respect to y. So I have ddy of e of y. I differentiate this side ddx of x. So when I differentiate this side, I'll end up with my ey. When I differentiate this side, but here I'm differentiating with respect to y. So when you differentiate this, you get ey, but with respect to dy. Then this side, when you differentiate, you get 1, but with respect to x. So what does it mean? When you divide through, you get dy dx is equal to 1 out of e power y. But what is e power y is the same as x. So you get dy dx is equal to 1 out of x. So that's how you differentiate natural log of x. But whenever you find a natural log of x and now you are differentiating it, what you do, always check what you have here. And then you say that when I differentiate x, I get 1 divided by the original thing. In case it was natural log of x squared, differentiate this, you get 2x divided by the original thing function you differentiated, which was x squared. So that's how you differentiate natural logs. I'm still using the chart. What is the maximum topics per item? Now that one, it depends, but at least there can be three topics in one item. Or in case you are lucky, it can be 1, but it can be 3, they can be 4, depending on how many items are in that particular section. Always we look at the 2/3 when we are setting those items. What if the force is acting on a particle at an angle below the horizontal? Yes, it's still the same thing. Still you resolve in the same thing, Zana. Any chance of, yes, we shall have facilitations for other subjects as well. So what of significant, what do you do when 3 and you have, so what of significant, what do you do when they need 3 and you have? Now, when it comes to significant figures, someone is asking me about this. And now, when you look at this, one of the conditions for significant figures, you need to remember that we have what we call trailing zeros. We have what we call leading zeros. Let me start. Now, leading zeros are zeros that appear before a non-zero digit, like this one. Now, any zero that appears before a non-zero digit are not significant. So this value has just one significant figure. Now, for this case, this zero is not significant, not significant, not significant. So this particular item, this particular number has 3 significant what? Figures. Then we have what we call trailing zeros. Trailing zeros, like the way you hear a trailer. A trailer comes after. So any zero that comes after non-zero digit, let me say 4000, these ones are considered significant given that they are not as a result of rounding off. Now for this, you shall say that these are 4 significant what? Figures. Now if it was for this case and they had asked you for 4 significant figures, then you could add another significant figure on it and you make them 4, because this is just a significant, it's a placeholder, but it qualifies to be called a significant figure because it is a trailing zero. Now, Mother Kevin, the total scores are determined by the weight for each item. So there is nothing like 5 marks, 5 marks, no. there is a way those items are weighed, and they give them the weights depending on how heavy the item is, how many concepts have been tested in the item. So what I need you to do is that always make sure that you write comprehensively. For you write, don't leave any doubt when you are writing. Write and check that you have answered the problem within the scenario, such that anything they look out for, you have it within the scenario. What if the ranges don't give a uniform class width? I don't know. Rena College, I don't know what you are talking about. Maybe you could throw more light. I don't know that you are meaning the other thing that you are saying. When is the next seminar? We are going to have 2 full weeks of facilitations for all subjects, starting next week, after this week, the other week, which is 14th. Excuse me, sir, are we having the old grading system? No, we shall have a new grading system. And please take note that we don't have points, that 17, 20, no. Yeah, but we shall have a grading system that fits the competence-based curriculum of ABCD, but we shall be guiding you accordingly. What if we are answering a number that requires graphical representation? Is it a must write everything on a graph that is in the table, etc.? Now, when you are answering something that requires a graphical approach, now make sure that your graph reflects what is within the scenario. When you are labeling your graph, let me say, in case your graph here, they have used the, let me say they had time, put here time. In case this was height, put there the what? The height. Then put the different values. In case it is a scatter diagram, put a good title and even have a scale. Like, do not leave anything for the examiner to doubt your answer. And here we are answering what happens in real life. Whenever you meet any graph in real life, you'll find that these graphs have titles, they have scales to guide you, and they have been labeled very, very well. So name your graph very well. Do not leave anything of doubt. More on approaching trigonometric ratio, function, or different signs. Now I think you are talking about solving. Let me hope that's what. Now, whenever, dear students, let me say you are finding the value of theta, and maybe you have remained with an answer like, let me say 3 out of 4. I always encourage that, please, dear students, make a sketch. You know that in this quadrant, all this is sine, tan, and this is cos. What you do, that you look at the sign of the ratio you have remained with, that this ratio is a positive ratio. Ask yourself, where is sign positive? That sign is positive in this quadrant, sign is positive in this quadrant. That means that the first angle you are going to get is going to be an angle here. And always when we are measuring angles, we measure them from the x-axis. Now the second angle is going to be here. So when you are finding positive angles, you'll just turn like this. Take an example. When the angle is 3/4, you'll find that the sign here is going to be 48.59. So that means that here you have 48.59, and also here you have 48.59. So that means that when you are finding the first angle, you'll just come here and find the answer. That is 48.59. And always when we are measuring, we start from the positive x-axis and we go in the anti-clockwise direction. So to find the second angle for sine, I'm going to move up to when I meet this reference line of mine. Then I will know that to get this angle, this is 90. Then I know this is going to be 180 minus the 48 point something, and I get 131.409. Now, in case you find that the domain has negatives, let me say they have given you negative 360 to something. Negative means that you are moving in the clockwise direction. So for such a case, it means that I'm going to be moving from here, I move up to when I meet this point here. So that means for that case, I'm going to come and say, this is 180 plus 48, 180 plus 48.59, and then I'll get my answers 228.59. But since I'm moving in the clockwise direction, I put that is negative. Then I make another round that now I want to go there. I'll move up to when I reach here. then I know that that one is going to be my 360 minus 48.59. But now since I'm moving in a negative direction, that is going to be 331.41 degrees. That's how we use the quadrants. In case the quadrants, let me say you had got cos theta and you had a negative 3 out of 4. Now, when you are placing to get your reference angle, don't put this negative. This negative shows you the quadrant where cos is negative. So cos is negative where? Cos is negative here. Make your good sketch. Cos is negative where? Cos is negative in that point. So what are you going to do? In this point here, you are going to place your reference angle. The angle you get here, you just say theta is equal to cos inverse of 3 out of 4. Then get that first reference angle 3 out of 4, and then you'll get your answers 41.4096 degrees. That's what you put here, 41.4096 degrees. Even here, it's going to be 41.4096 degrees. Then make, which angle do you need? You need this angle here. And then you'll get, now you know that it's going to be 180 minus that, and then you get 138.59 degrees. Make another round up to when you meet this reference line, get 180, then plus 41 point, that is 4096, and then you get your answer as 221.4096. That's how you can do with that. So the negative shows you the quadrant where your angle lies. Which quadrant? Always check here after solving. Check on this. And when you find that you have SADS, SADS means that we want you to have accurate answers. So make sure that you work with those SADS very well. Some of your calculators are very okay. Now, in case you find that here, they gave you are remaining with the SADS. Here we are looking for accuracy. So never place your calc and say, what is root 3 out of 2? Then you place root 3 divided by 2, and then you come up with your answers 0.866. Here you are going to miss out on accuracy. That's why in numerical concepts, you looked at SADS such that you know how to apply them when it comes to trigonometry. Then there, make sure that you get the accurate answer. You get the accurate answer. How do you find out? Bruce, okay. Integration by parts. Integration by parts. I think that one, I think I'm going to refer you to YouTube. I think I've done a lot of integration by parts, so you can find something there. I will show you where you are going to find it. In case it was west 30 degrees east, still you do the same. This is west. Now that one, they cannot give you that kind of direction. But in case it is that, because now that one you cannot turn. When they give you west, remember this is east. So they cannot give you such a direction. So they cannot give you such a direction unless there is a problem somewhere. Because here, someone can either take the clockwise direction. Someone can turn like that, west 30 degrees east. But that one would have some issues. Would have some issues. But in case it is like that, then that's how you turn. Because when we are measuring the angles, we start from this, and we always take this kind of direction in bearings. We always take the clockwise direction. So you get 30 and east is towards this side. So that's what you can do. After resolving the how do you show the resultant force? Now, like after getting, I'm still answering question. Now, after getting the resultant, let me say you have got your resultant as maybe 3.45 IE, then minus maybe 4.52 J. Now come and first make a sketch. For you to get the magnitude, I think you're asking for the magnitude of the resultant. Come make a sketch that this is positive. Positive always looks like that. This is negative. I'll come and I make a negative like this. So this is going to be my 3.45 Newton force. This is going to be my 4.52 Newton force. Then the direction of the resultant, this is the resultant. Resultant means that the line that joins from the starting point to the finishing point. This is what we call the resultant. So to get the direction, this is the direction you get. So you can say, let me say this is theta. Then you say that tan of theta is equal to opposite, which is 4.52, divided by horizontal, which is 3.45. And then you get the tan inverse of this particular thing, you are getting 4.52 divided by 3.45. And when you get the turn of that, of the answer there, you'll get something like 52.646. Now, this 52.646 is what we call the direction of the resultant force. But when you are giving the direction of the resultant force, please make sure that you come to the starting point here. You draw your thing like this. Then you give it in terms of direction. You can say that the direction of the resultant force is 52.646 degrees below. Now, this is what we call the x-axis. This is the positive, this is positive, this is negative. Then you say below the negative horizontal with the 3.45 newtons. So give the direction with which force you have measured it from. Another person could as well even give it like this, and they give that particular angle. So when you give that particular angle, you don't need now to add on below the negative horizontal, but you say it is 52.646 below the negative horizontal with the 3.45 Newton force. That's what we call the direction. What do you have to say about vector mechanics, math, paper 2? Yes, now still that one can appear in paper 1. That one can vector mechanics. It is in differentiation. It is in calculus. So that one is in calculus. That's where you can find it. So in calculus, they can bring for you that mechanics bit of it. Will they consider average for ranking us? Now that decision has not yet been taken. Decision has not yet been taken. How do we add and subtract logs and lines? Now in logs, what you need to know that subtraction, let me say AB plus log of AC, as in logarithm addition. The moment you see addition, then you need to know that as long as the bases are the same, that is the multiplication, B times C. In case it is what? Subtraction. Then that means that is going to be division, as long as the bases are the same. However, if you are dealing with a base and you want to write it in the same base, then it means that you go on and apply the rule. So you just need to know these rules concerning logarithm. The same rules apply. Still, when it comes to natural logarithms, where you find add, you multiply. You find subtraction, you divide. The responses for the seminar will be shared. Advise us about the circles. Now, when it comes to circles, you need to know how to find the equation of the circle. When you look at the seminar items we shared with you, you do notice that there is an item about circles, learning how to find the equation of a circle given 2 points. So you need to know how to find that. Then also you need to know how to solve simultaneous equations. Now, when it comes to simultaneous equations, they can cut across the different elements. They can cut across, because you will find that in geometry, you can solve simultaneous equations given if they have given you 3 points, and now you are 3 points, and now you are finding the equation of a circle. You can solve a simultaneous equation. In algebra, you can find simultaneous equations. When it comes to mechanics in paper 2, you can solve simultaneous equations. Now, you need to know that simultaneous equations can cut across everything. The same thing with errors, with percentage calculations. They can cut across some of the items. Flowcharts, that one is in numerical. That one you'll find it under iterative methods. Now this one, let me see whether I can be able to see it. Now, how can you tell that something is the cumulative frequency? I think I need to download. There is an item they have sent here. Let me first download the picture such that I can see it very well. Now, always, number one, you can first read through the item. Sometimes they will tell you that the total the number of students in a school is 180. Now, that one can give you a bit of a hint that the number is 180. In case they have given you such a hint, that one is very okay for you to do. Then number two, read through the scenario. Sometimes they can put that the cumulative thing is this and the other. Then through that, you can be able to tell whether now this is cumulative frequency, but always they will give you clear indicators. They will be giving you clear indicators that show that this is what this is now for this particular item. It would be very hard for you to tell that this was cumulative frequency, but the best way they would have informed you that there is cumulative frequency, it would have been that he discovered that maybe the 180 people were struggling with malaria. If that statement had been put somewhere, then it would be a good indicator, but it didn't have any good indicator that it required that kind of knowledge. So there was a gap there in the item setting for that particular thing. Okay, I'm still looking through the chart. What if A is 30 degrees east from out? That one now I've not understood. At what time? Okay. When are the calculators supposed to be in radians? When you are dealing with the trigonometric functions, your calculator will be in radians. However, please, you always need to check. You need to know that sine, cos, tan, all those sec, cosec, and the rest of that, whenever you find that they have just written something like this, many times for radians, you'll find them using the pi. You'll find the pi there. But in case they have just written sine 30 and they have put degrees, then you need to know that those are degrees. But I want to let you know that trigonometric functions, when you are dealing with them, you must deal with them in radians. More so when you are making any kind of calculation. When you are dealing with the numerical, because radians is the standard unit. Like the way you see length, the standard unit is meters. So when you are dealing with the Newton-Raphson methods, you are dealing with the trigonometric, then have your cali converted to radians. How do you calculate Fermist value in correlation when one of the pair is not completed? Now there you can use the iterative approaches. That's where you are going to, when you look at that's where you're going to use interpolation. That's why you can use the extrapolation. That's why you can draw those particular values and then you estimate using the line of best fit. But the best approach is using the iterative methods of interpolation or extrapolation, or you can draw that graph and then you estimate using estimation approaches. In what situation do we get cumulative frequency? Cumulative frequency is when you are finding now one, when they have told you when things concern quartiles, when you see things concerning median, that's when you can have cumulative frequency. But also it depends on the graph, you are dealing with. But the moment you see quartiles, you see medians, then you need to know that cumulative frequency is needed. No, it will be, the scoring will depend on the item. It will depend on the item because different items weigh differently. When you check the sample paper, you may have noticed that item 1 was so light, but when you look at other items were so heavy. So the scores cannot be the same. You'll find that some items are weighing 18, others 20, others 16, depending on how marks have been distributed. The number of items to be answered in each paper, 3 items. I don't know what fortunate you are meaning. Yes, it is a very good practice always to just say now conclusion such that the person marking or scoring you is able to see, is able to see what is taking place. Okay. Relative motion is examinable. Like meta SS I have showed you. Like the seminar items we sent you, we did not exhaust everything. There are topics that we are not able to attach, but under dynamics, relative motion is examinable. So we cannot exhaust everything, but I know during our revision week, we shall revise relative motions, but it is examinable. Yes, can there be more than one item? Yes, that is very, very possible. You can have 2 or 3 more topics. When you look at those seminar items, you look at sample papers your neighbor has sent you, you'll notice that one item could have normal distribution and you find it has statistics. You find one item as having connected particles, having friction, and the rest of that. So, for scenarios that require the Bayes rule, you can check out the sample paper UNEB gave. That sample paper had the Bayes theorem. Also, if you are whenever you are reading things that involve given probabilities, you'll find yourself that you need to apply. But use item 3 of the UNEB sample paper, you'll find that Bayes' rule. Elaborate more about intervals and ordinance in trapezium rule. Now that one, allow me meta SS. I think I will share with you. I'll be sharing with you. I'll be sharing with you. But we say that when okay. I don't know now what we are going to do because now I think but that one I'm going to show you something I think about that. But I want to let you know that when we talk about the trapezium rule, we talk about those things. You need to just understand what we call ordinates, that when we are talking about ordinates are more than sub-intervals. So ordinates, you subtract the 1. Then sub-intervals, you don't. But the most important thing is for you to understand how those things come about. That when you talk, let me say this is our diagram. When you talk, when if this is our diagram, this is like this is 1, 2, 3, 4, 5. Now these are 5 ordinates. Any line you see here, we call it an ordinate. Then now this trapezium is what we call the sub-interval. So now here, this particular one, it has 5 ordinates. But when I'm talking about the trapeziums, it is this one, this is 2, this is 3, and this is 4. And now that's what we call sub-intervals or strips. So ordinates are lines of the trapezium are what we call the ordinates. Then the trapezium itself, a complete trapezium, we call it an interval or sub-interval. Okay. Tomorrow shall we have yes, yes, tomorrow we shall have a seminar at 2, but I think tomorrow we shall focus on mechanics and other items that we have not been able to solve. No, the grading, dear students, is going to be totally different. The grading is going to change and it's not going to be like the old curriculum grading. I think I've already told you what to look at under trigonometry, not the different concepts. Those ones will. Please, numerical method, things are in paper 2. Is factor formula applicable? Yes, factor formula is applicable, depending on the scenario. Yes, we shall have other seminars for other sessions. Tomorrow we shall meet, but we shall mainly look at other items that we have not been able to do. Ooh. I think oh, okay. 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 Now allow me, I'm going to share. Let me first share because now I've seen that some of the challenges you have, we have already handled them. We have already handled them. So what you are going to do, we've already handled many of the things that you are mentioning. We have already handled some of the issues you are mentioning. Now, what you are going to do what you are going to do, because now you are mentioning quite a number of topics that we may not be able to do now. Now, what you are going to do, dear students, you'll come to the Holistic e-learning platform, this YouTube channel. Then check under the playlist. The playlist is here. Now, you'll find that I have taught different topics depending on the need, your need. I've taught differential equations. There are a number of scenarios you can meet here. I've taught projectiles. Come here, learn about projectiles. People were asking about trapezium rule. Trapezium rule is here. I've taught trigonometry is here. Integration is here. Partial fractions are here. If you have challenges with vectors, come here. Issues with the differentiation to come here. If you still have challenges with your general paper, come here. If I think those are the ones so far you'll find here. This probability, yeah, so you'll find them there, and others we shall be adding them accordingly. But you'll come here. These are complete sets of topics. So in case of any issues, come for many of those topics you are covering, and maybe we shall keep adding in holiday when you go back. We shall keep adding more and more topics. So just come to this YouTube channel. You'll find many of those things you are asking about. Yeah. These are scenarios. You'll find the scenarios on each of those topics. We learned them in January. Okay. I think tomorrow we shall start at 2 p.m. We shall start at 2 p.m. Those who kindly, we shall present or we shall look at items that have not been presented today. Those are the items we shall look at tomorrow. Those who are still asking for the seminar items, let me check. Let me share them here in the chat. Okay, so we shall use the same link tomorrow, and for any school that is going to present, there will be those items. Matuga College you wanted, there will be those items that we have not gone through, that we shall go through. Also, we shall look at mechanics, we shall look at the compulsory items at least, and then we shall build up from there. I repeat, the total number of items to be attempted are 3. 3 items for each paper. But I think you'll use this recording because that's what we started on in the morning. Okay. 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 I want to say that we are going to end here. I'm seeing some questions. I don't know whether I'll be able to answer, but Saddam Yassin ask, Arnold, and then Joshua. Those are the only 4 people I'm giving the chance. Okay.
Sir?
Yes, please.
So I also want to find out, like, if you meet a sir, can you hear me?
Yes, please, I can.
Okay. Like, if you meet a simultaneous equation when it is
With it?
applied in a part, for example,
You are
when
saying,
it is
come again?
applied in any part,
Come again, I'm
like
not
when you
getting
meet
you.
a simultaneous equation,
Hmm.
if you meet a simultaneous equation,
Hmm.
when it is applied in a contrast, can you simply use calculus to solve it, or they expect you to do it stepwise?
Yeah, now,
And
like I've
also,
said,
like, if I want to,
I repeat, I'm saying that when
and
you
also,
meet any, okay, number one is that when you meet those spontaneous equations, kindly solve them. Don't use a calculator. A calculator, just use it to prove whether your answers are correct, but show the working on how you are solving it.
okay, sir. Thank you.
Okay. Okay, I think I'm going to invite Matia Mulumba. Matia Mulumba, unmute. And then I think we shall have one student from that school pray for us. And we end here.
Good afternoon, sir.
Yes, good afternoon.
Good afternoon.
Yes, good afternoon.
Samia was just having a simple concern here.
Yes, please.
Like, as we are going to have maybe, for example, item 1. That is paper 1. Is there a possibility that all the topics that are there, like coordinate geometry 1 and 2, trigonometry and vectors, all may appear in one item?
The answer is yes. An item can come when all those things have been mixed in one item, whereby you find that part A requires you to use coordinate geometry 1. Part B requires maybe coordinate geometry 2. Part 3, when you look at, I think, the seminar item, the seminar item, there is an item, let me show which item was that. But when you look at one of the items, when you look at item number 3, you may notice that item 3 of the seminar, the first part was talking about vectors. The second part brought in the issue of trigonometry. So it is very possible that you can find a scenario having all the 3 items bounded within one item. So it is very possible.
Okay, so that's what I wanted to know.
Okay. Can you lead us in a word of prayer?
Okay, it's fine, sir. Okay, let's believe and pray. Our loving Master, we want to thank you for this day. We want to thank you for everything that we have studied today. We want to thank you for the gift of life and protection, providence, and everything, Lord. We appreciate it because we know that, Father, you are the provider, and without thee, we are not able to get everything that we have got. We want to thank you, Lord, that you have made this session successful, and we have been able to learn a lot on how we can progress in our academics. We believe that, Father, you give us the memory that we might remember everything wherever we go until the day we sit for our final exams. Give us the blessings, Lord. Give us the anointing. Give us the understanding, the knowledge in everything that we do, and continue guiding us in everything that we are going to be doing from now up the time we shall sit for our exams. Bless our teacher and all people who have been listening out to this recording and everything that is going to be going on. We pray that, Father, you lead us, control us, and give us the knowledge and understanding in everything we do. We pray that, Father, you come and intervene in our academics and bless even our parents and bless even our colleagues and everywhere who need thy hand. We pray that, Father, you continue blessing them in the mighty name of Jesus Christ, even as we are going to meet tomorrow. May you give us the gift of life once again that we might live. In Jesus Christ's name, I pray and believe.
Amen.
Amen.
Thank you so much, everyone. Thank you so much for joining. Let's meet tomorrow at 2 p.m. to discuss the items that we have not been able to discuss. Thank you so much and have a lovely day. See you tomorrow using the same link. Yeah, bye-bye.